There. This is stream number 20. My journey to make my own keyboard. So let's see if stream is going. Yep, seems to be going okay. So I finished the routing and layout and did a bunch of extra cleanup and actually sent this off to the board house. So hopefully the keyboard PCB will be built right. I've only so far found one problem, which I have a workaround for, and it's that some of these standoff holes are too close to other parts. So this right here is a socket for a switch, and from the center of this screw hole to the edge of that, it's only 3.3 millimeters, right? So the problem is when I printed out this test standoff, I could only get it to work if I made the diameter of that standoff, I think it's 9 millimeters, so 4.5 millimeters from the center. So that would extend all the way out to here, the middle of this pad, which is bad because the pad, the socket sits right on top of that. If I show you in the 3D viewer, flip the board, well, wait for it to load first, then flip the board around and then zoom into any of these. So if I tilt it a little bit, it becomes more apparent. If there's a plastic standoff that has to touch all the way around the board at a radius of around 4.5 millimeters, it's going to run right into the metal edge of this switch. Also, a few of them have this other problem where they run into the NeoPixel here. So my solution for that is going to be, after I get the PCB board back, I am going to probably shave off a little bit of the 3D printed case that has the standoffs that sits right on the edge here. So like a cutout, probably cut right here and cut right here after I put in the nickel inserts. So not too bad. Anyway, so schematics all done. I'm going to leave it up here in case people come and ask you what the heck I'm working on. I am 3D printing something right now. This is going to be like a base plastic that the board sits on top of. So here's the 4 standoffs with the holes there where we put this nickel inserts. So again, it's just like this prototype piece. You get good lighting on it, you'll see there's a flat part, and above the flat part there's, I don't know, 2 or 3 millimeter post with a nickel insert with where the screw screws in. So that's right here. Hey there, Lazy Guru. How are you doing today? So I am printing this right now in the other room, so I might occasionally go AFK just to make sure the printing is going okay. So what I did was I have an export of the PCB mask of the edge of the board. So that's this really thin black line and these rounded corners here. And then I just designed this 3D model around it. Added the standoffs in the exact spots where these holes are in the PCB. So where these 4 holes are, 4 larger holes, are right here. And I made a cutout here for the USB-C connector. Just, you know, being really conservative, I cut off a fair amount. So the USB-C is going to plug in there. And that's about the level that the circuit board's going to sit on top there, right? So it's going to be pretty... right here is where the connector's got to go right in and hook into that. So the left and the right are not symmetrical, though. So I need to do the same thing with the cutout from... I did the right, so now I need to do the left. So that's what I'm going to do a little bit today. And then also I want to go into the software again today and work on the keyboard scanning. Right now, when we scan keys, they're just either on or off, and they're constant scan codes based off of either 4 or 30. Plus whatever switch number it is, so that gives us like 1, 2, 3, 4, 5, 6, and the other side A, B, C, D, E, F. And I did hijack one of them so that we it's this left one. This, instead of doing a 1, it's a shift. So if I do A and then shift A, so I can do I did the test of the modifiers. So what I want to work on is mod+tap, which I put it into my notebook here under other documents. So I found, with the help of Adam Learns, I found this document that goes, if I zoom in on this, mod+tap behaviors in QMK. So what is a mod+tap? That's a key where if you tap it, it has one function like F, but if you hold it down, it's a modifier like shift. So you run a timer based off of some amount of time, so they call it tapping term, and if you press and then release it before the tapping term, it's just F. But if you hold it longer than the tapping term, it becomes shift. So I want to put that in because I'm going to use that. I use that quite a lot on the Corn keyboard I have now. So let's collapse that and then move this around so we can all see it. So that's both for modifiers and also for layer switching. So we might have a layer tap where if you just tap it, it's an F, but if you hold it, it switches to layer 1, right? So to do this, I'm going to have a timer that's measuring this tapping term, which I think for my Corn keyboard I'm used to is 250 milliseconds. And so we'll have to track the time that we press keys down, and then when they're released, see if it's less than tapping term, it's the letter. If it's greater than or equal, it's the shift or layer switch, right? And there are also other behaviors, like if you press and hold Control and then press and hold the shift or F mod+tap, the control is actually, and you release Control here, it actually holds the control, like preserves it until it makes a decision on if it was a shift or an F. So here it was less than the tapping term, so it's an F, so it's Control F, because you hit the F here while you were holding down Control, so it kind of makes sense. Nested key presses, like you pressed the J here and you released it here, but you don't actually see it here because you don't know if that's an FJ or a Shift J. So if it's I think it is, yeah, it's a Shift J. I thought this would actually be an FJ. At what point is it a Shift J? Oh yeah, that's right. There are two different behaviors. The default in QMK is that this is a Shift J, but if you do ignore mod+tap interrupt, and since this is less than the tapping term, it's an FJ, right? And then there's permissive hold, where it becomes Shift J right at the edge of the J instead of at the end of the MT. So there's slightly different behaviors so we can play around with. Yeah, rolling, pressing of another key. So if you hit the shift and then J and then release the J, the shift is held down for right when the decision is made, I think. Oh yeah, right when we release this, it becomes a shift and then J, but then the J is held down till the end of J. So the different behaviors. I want to kind of incorporate these into my keyboard because I use these on my Corn keyboard. All right, I'm going to go check my printer, and then I'll be right back to basically fill in the 3D model for the base plastic around the left-hand side, just to make it look like the right-hand side. So let me go check the printer really quick. I'll be right back. Okay, we're all good. So let's do some Blender. I'm getting a little bit better at Blender. You can see I've managed to figure out how to make curved pieces that basically I did a Bezier curve and then converted it into a mesh and then added it to the base part. So let me get the dimensions on this again. If I remember right, yeah, it's 8 millimeters tall, and I decided that the 0 point is the top of these. Yeah, so where the board rests, the bottom of the PCB is 0. So the plastic extends down 6 millimeters and then up 2 millimeters to sort of match the PCB. And this inner dimension is -4. So that means the base is 2 millimeters tall, and then the walls are 6 millimeters tall. And the standoffs are also 6 millimeters? No, that's not right. It goes from 0 and then, yeah, so they're 4. This is 4 millimeters tall, and then 2 more millimeters to the bottom of the base. Okay, so let me work on that. I'll do the notch later. So let's start with making a cube here. And grab it right here, put it nearby. We'll make it go to, so it needs to go from +2 to -6, right? So half of that is -1, -2, -2, and then 4 in each direction, right? So 8 total. So right about there, right? And it kind of matches the thickness of the other board. Right, okay. And then let's just get the rough dimensions of the board. So I think it's like 120 by 100. And then let me grab an X and Y and kind of put it in the right spot. Oh, I don't want to make it 8 tall. I want to actually make it 2 tall and put it down at -5. Because it rests, that's the bottom piece. The walls actually go up another 6. Okay. So centered there. So I need to make it a little bit wider and taller. So let's go to 140 by 120. All right, we're getting there. I want to be precise. The inner wall is at a Y of 6.7 and to 10, so like 3.5 millimeter away from the board. Okay, I needed to measure from the outside of the board. So from here, 3.7 to here, 10.4. So that's 6.5 millimeters. So we want the outer edge to be 6.5 millimeters from the board, roughly. It doesn't have to be exact. So if that's at 163, minus 6.5. I mean, this is close enough, right? Yeah, I'll say that that's close enough. So I'm kind of eyeballing it. I think it's more or less correct. Actually, you know what I can do? I can drag it over and see if it's around the same dimensions as the other side board. Okay, it's a little too wide, a tiny bit too tall. So a little bit too wide would be on the X dimension. So let's reduce to like 135 and like 118. All right. Let's grab it and slightly move it down. Yeah, that's pretty close, right? That's pretty close. All right, so let's put the walls up. So that would mean doing a loop cut. Help me out. There we go. Loop cut, and then drag it over to 3 millimeters from here would be 158, roughly. 158.1 well, 3 from here. 158.9. So like right there. Is that right? I guess so. And then let's make another loop cut over on this end. So 170.6 right there. Okay, and then let's make the walls on this side. So 138, so 135.45. Like right there. And then on the left, so 217.82. No, I'm looking at the wrong dimension. 3.48 plus 3 was 6.48. Right there. Okay, and then what I'm gonna do is select the top actually, and zoom in and move over there. Yeah, the top layer, and then I'm just going to grab them and take and drag them up. Oh wait, I want to actually extrude, don't I? Extrude in the Z direction. Yeah, extrude in the Z direction up to 2. Actually, I can do that and just type in 2 here. Okay, so there's one wall, and then do the same thing over here. So grab those. No, just those 4. And these 4. I need to hold down the shift when I did that. Okay, and then extrude in the Z direction up to 2. Oh, that didn't work. That made it crooked. Extrude Z direction. Oh, no, it's X Shift Z? No, I think I have... Oh, I know what I did wrong. I have one extra vertex selected there. There, okay, got it. 2. All right, and then for these final walls, actually what I can do is just add geometry. Fill that. And fill that. And then fill the top here. All right, and then we'll do the other side. So do the inner wall. Fill, and then the outer wall. Fill, and then the top. Fill. Okay, so now I have like a coarse thing. So we can like make these diagonals just really easily by just dragging this corner over, right? Let's center this. All right, zoom in. Okay, grab this, and then we're just gonna grab the whole thing. Stay at the same Z coordinate. Oh, I didn't get the inner point there. Right. So let's drag it so that it's like up to here, right? Oh, before we do that, I need to make a cut in the wall right there, right? So let's do a scissor cut, knife cut, I mean, right here. All right, and then enter to confirm. Okay, so now I can just grab those points again. And the inner one. Okay, and then like this. Oh, there's an extra point out over there. Grab and then constrain to Z, and then I can just do like that. That's pretty close, right? There we go. All right, what happened to that? How did I get an extra vertex there? What is that right there? I think I just want to dissolve that vertex. Yeah, somehow I got an extra vertex there. Okay. Cool. So then this one I'm going to do a Bezier curve on. This one over here, I'm going to do the same technique I just did before. I'm going to cut right there with the cutting tool. That didn't work. Try again. How come it's not cutting those? Cut! It's not doing it. Okay, there, cut them. Okay. Enter. Ooh. That's not what I wanted. I'll get this some point. Oh, do I have to drag from here? Oh. Let's just cut again. How come it's not cutting there? I don't know what I'm doing wrong. What if I just do another loop cut right there? Yeah. Actually, there we go. Loop cut was better. I should have done loop cut from the start. Okay, and then let's loop cut over here. Right there. Perfect. Okay. Well, thank you for the follow. Don't mind my horrible skills at Blender. I'm pretty much a noob, but I know enough now to get things done. So let's grab that constraint on the axis. Whoops, I don't have all the points that I want. Grab that point as well. Do I have the bottom one? Oh, we're missing a point down here. That didn't get cut down there. Knife. There. How do we get an extra point there? Well, we can just delete that vertex. Delete and dissolve it. Oh, I see what happened. Let's grab and constrain to the y-axis. Get it right about right, and we'll just add an edge. Fill an edge there. Okay, so let's try this again. Grab all these vertices, and then, actually I don't need to do that. Just grab all these ones, right? Grab that, and then should be able to just grab the whole thing and then... Why am I not... Am I missing a point? Oh, there's extra points. Okay. So let's fix that by selecting all, mesh, cleanup, merge by distance. Okay. Now, grab these points and the inner ones. I need to hold shift when I do that. Okay. And then grab, constrain to that. Grab, constrain to axis. There we go. Actually, okay, I need to move those other points around, right? That's okay. We can just leave them. There. Cool. Getting there. Okay, for this slant, I can cut right. I can subdivide right here. Right there. right? And then just move those points. Make sure I got them all. Okay, and then grab constrain to XY. Let me make sure I can see it all. Grab, constrain, okay. And then what we'll do is we'll do the curves in a bit. Let me go check on my print. I'll be right back again. Sorry for the AFK. I'll be right back. All right, I'm back. So printer is almost done. Another 15 minutes. It'll be done. And then I can print, maybe by that time I'll have this done and I can print the left-hand side. I don't know if I'm that fast. So these curves are a little bit more tricky. What if I clean up this non-curve here first? So the way I did this on the other hand, on the other side, was I basically move this point in so it's not so sharp. So we can just like drag these around, right? Grab and then just move them in. And then we can even like subdivide this, or I can actually just grab these right here and move these in. Like there. I mean, that's probably good enough, right? Just a slight curve of the corner. We could add more if we wanted. I don't know if I'm going to bother. That's probably good enough, right? These three okay, this one I can kind of do the same thing, actually. Yeah, I can kind of, you know, just kind of do this one in a rough way. Just grab, constrain, and then I can take that inner one and I can extrude along the XY and put, oh, that's not going to work. Do I want to edge cut that one? Let me think about that. Maybe. And think about this. What happens if I do an edge cut here? That's not right. How about... Do I need to pick, like, plain edge cut? It's not helping me. Oh, here you can cut it here. I just want to add some extra points. Just a really cheap way to add points, right? So now we have some extra points we can play around with. So I can take these... Oh, that's not what I wanted. Go to points again, and then grab these and then just move them over here, right? That is an extra point, I think. Hold on, let me select all mesh cleanup, merge by distance to get rid of those extra ones, and then grab these two, grab them, constrain, and we can just kind of like, well, maybe I should do a curve here. I was thinking of just grabbing them and putting them like here, and then grabbing these two and putting them here, but maybe I do need a curve here. I don't know. This might be good enough. So let's clean this up a little bit, like move that out to there, move that out, I don't know, here-ish. That might be good enough. Okay, let's just go with that. These, like this really curved one, I'm gonna do a different approach. So let's save. What I'm gonna do for this one is just go to object mode, add a curve Bezier, and then move it over there. Put it at a Z of 2. grab and put it over here. Where exactly do I want to put it? Like right where I think the wall should be, like right around there, right? And then I'm going to go to edit mode. I'm going to grab these individual points and kind of put them along the wall where it's going to start to curve. So like one right there, and then one over here. And then I'm going to move the control points around. So this goes over, actually if I do rotate, that works too, right? Align them, we basically want to line them up like that. Rotate like that. And then we want to move these way out. So, or is it, I can't remember which is which to get them. Is it this one I gotta move? Yeah, that one. Okay, this one way out. So, like that, and then this one way over to here. So, yeah, I need to move this one back in. Or this one doesn't really matter, right? This one doesn't matter. It's these inner ones that matter. So see, it affects how much of a bulge we get. So something, I'm just basically eyeballing it. Like that's probably good enough, right? So now here's the trick that I learned earlier today. We're going to do object, convert to mesh. And then edit mode, select them all, extrude in the Z direction, go down to -6. So that lines up with that wall, right? And then we're going to select all again, and then extrude XY out to where the other existing walls are. You know, close enough, something like that. And now we're going to merge it with the main piece. So object join, and then delete the walls we don't want. So deleting all these points. X vertices. X vertices. Oops. Okay, undo. That's not undo. There's undo. Okay, so yeah, I'm gonna have to put, was it not delete them, but dissolve them? Yeah. Okay, the problem is I have to merge these all, right? So yeah, edit, select all, mesh, cleanup. Is it fill holes and then mesh cleanup, merge by distance? I think the problem is that these don't actually connect. Yeah, I need to move these, move this, let's X-ray through. I need to move these a little bit, like to there. And this one and this one have to move also in the X direction there, because they're not connecting, right? And then I think I need to do this side too. Hold on, zoom out, let's center it. All right, and then zoom in. Hold on, what side are we looking at? That's the bottom, right? Hold on. Turn off X-ray. It's upside down. Okay. Okay, I think that's right. So, okay. Let's do this one at a time. What happens if I delete these vertices? Okay, that's fine. And then delete these. And then delete these. Okay, that's too much. Delete this one. That got rid of that wall. I can get that wall back, actually. So this... Actually, let's do the bottom first. fill that, and then the side, fill that, and then the top. And do I need to do an inner edge? No, that one's good. Okay, I need to delete this one. Okay, the bottom got erased, so... Well, that's unfortunate. Need to add the bottom back. Okay, well, let's do the side first. See, I'm not an expert at this. I kind of fumble around, but I get it. I get what I want done. I'm not going to worry about the bottom yet. Let's just do the side. Fill, and then the top. Fill. And the inner one is there. So it's just the bottom that got deleted, right? Okay, and then let's delete these while we're at it. Okay, that I can't do. Let's edge cut that one. Or actually, what would be better is just to what is it? Copy or cut? I can't remember. Cut along here. Yeah, and then we'll let me just move these on top of here. Then I can let's do the same thing here. So cut tool. That, and then grab them along the y-axis, put them on the wall. Okay, now I should be able to delete these, right? No. Actually, I can reform the bottom. Yeah, I can. Let's hide these curves for a second. Okay, I need to clean this up and fill in the holes. So, oh, I see what happened here. Yeah, we need to add a is it just E? Z? No. I think what I want to do is cut there. Yeah, just cutting and I can delete, dissolve that one. Okay, and then grab that one and move it over to there. Oh, I see what happened. The wall doesn't quite line up. Okay, well, let's undo. Let's just form this edge. Yeah, okay. That'll work. And then let's add this face here. Right. Okay. Let me delete that one and that one. Okay. We're getting there, right? I just need to reform the bottom again. It got deleted. Ooh, I see. I need to, can I cut this one? Yeah. I need to cut that around. That's the outer one. Yeah, I need to put this cut at -4. There we go. All right. Oh, I missed one over here. Can I cut here? No. Almost there. Center things up again. Okay, we're missing a point there, so can I go to edge mode, just select that edge and then cut it? I mean, that works, right? I can, Didn't mean to cut that one. Can I just dissolve this one? Cool. That actually did exactly what I wanted. So then I can reform this edge here. Right. And then... Okay. I can delete all the bottom faces now. Hold on. Which one's which? Turn up X-ray. Okay, we're looking from the top here. So we're looking from the bottom. Turn on X-ray. Let's delete all these bottom faces. Am I deleting the bottom ones or the top? I'm deleting the top ones. Oops. And I picked the totally wrong ones there. I should just turn off X-ray. There we go. X-ray is screwing me up. Nope, I did it again. These ones. Yes, delete these. Actually, I don't need to delete them. What if I just add the missing one there? So, that's this one. Right? Yeah, so if we're looking at it from the top and we're looking at it from the bottom, I just need to fill in that bottom layer. So go around the bottom here. Wait, what's going on there? Oh, there's a hole of some kind right there. Ew. Okay, that's missing a face. Oh, and that's missing a whole bunch of geometry. Shoot. Okay, do I need to... Yeah. Okay, that's what happened. I guess I'm going to extrude up to -6. Or down, as the case may be. Oh, what happened here? Did I... I think this needs to be pulled in. Well, okay. I can just connect all these. Let's go way over here. This is missing. This is definitely missing a face. Wait, there's no vertex there at all? Wait, what? Oh, this whole thing is missing a face. Oh, shoot. Oh, that's right, because I don't need those. Shoot, I'm getting myself confused. The bottom just uses these points. Okay. We're just picking all these along the bottom. We're just gonna make a big face out of it. It's probably the totally wrong way to do it, but, you know. So hit F. There we go. Alright, now what are those extra ones on the top doing? My camera's not oriented correctly, so center it there. Center it there. Now I can zoom in. What am I looking at there? Oh, that face doesn't need to exist, so select these and dissolve them. There we go. Okay, so the bottom is filled in, right? So then there's the inner tray that we need to fill in now. That's these points here, right? Going around like here and here and there and there. All of these ones. All of these. These two. And that one. Hit F. Okay, there we go. I filled it in. Let's save. Select all, mesh, clean up, merge by distance. It didn't remove any. How about, okay, so I guess we're good. Okay, let's show the curves again. Okay, so that was, I made that way more complicated than it needed to be, but I do have a curvy wall here now. I think I want to clean up these points right here and move them slightly in. So let's grab them. All the way around. There's an extra one there. I don't need that one. Let's delete, dissolve that vertex. Okay. Let's grab these and then kind of move them in. Like, I don't know. So it's not so sharp. Actually, let's move that in. Let's move these outer ones a little bit even more in. Like, I don't know, like that maybe? That looks better. Okay, we have that nice curve. What's that extra point doing? I don't know. Let's just delete it. Dissolve vertex. It's looking good. There's an extra point there we don't need. Dissolve vertex. Dissolve vertex seems to be your friend usually. I don't see any other weird points. X-ray mode, we can look more carefully here. Oh, I need to make sure that the faces are all the right orientation. That was face orientation. Oh yeah, so a lot of them are backwards. Let's fix that. Let's pick all the backwards faces. I need to pick faces, please. So these are all backwards. So what we do here is we go to mesh, normals, flip. Okay, and then let's hide that. Okay, so let's do this big one, mesh, normals, flip. Okay, the interfaces are all backwards. Actually, what's going on there? Was there a face missing? I believe there's a missing face, a missing internal face there. It's kind of hard to see. But you can kind of see through the geometry. Yeah, we're missing one there. Okay, so let's add from there to over here. There we go. All right, and then let's grab faces again. This one, these all these all need to be flipped around to have consistent, basically normals that point out, right? So mesh, normals, flip. Okay. And then there's a couple over here I need to fix. Oh, that's a hole. Okay, these are not holes though. Mesh, normals, flip. Okay, there's a hole right there. Let's center our camera on it. It's probably a better way to center camera, but I don't know what it is. Yeah, where exactly is that hole? It's hard to see. Is it on the inside? Wait, which way is up now? Okay, upside. Camera was upside down. I think it's right here. There, these four. Fill that in. Oops. Fill. There we go. Now we've filled it in. So there's a dot now, right? We can pick that face. Okay, let's view or turn off that. All right. Hey, it looks good. Oh, this one's backwards. Mesh, normals, flip. All right. Okay, we have some over here we need to fix. These two. Mesh, normals, flip. Okay. Okay, the bottom is upside down, and also there's some around here that are upside down. Mesh normals flip. All right. Good. Now we fixed it. Hey, how are you doing? Design up a keyboard? Yes. Hey there, Blazar. I have the PCB done. That's what it looks like. I'm having this printed right now. It'll probably be back in a week or so. I got all the parts in today, all the switches, all the things. This is what it's going to look like when it's fully assembled. So this is the front. I have thanked some of the people who have helped me on stream and off stream. I have the Ferris and the Rust logos on it. This is the left and right split keyboard. So we're gonna when we get it back, we cut the board right here on these breakaway tabs, right? And we connect the two boards with these USB-C connectors, and our KB2040 controller boards sit on top of here, and then we have 36 different keys. So the keys are each, on the back, there's a socket that you plug the switch in through the board. There's a diode, there's a per key LED, and then, so there are 36 of those, and then there are 8 of these underglow LEDs that we added in the last revision. And there are these 4 through holes for screws. And that leads us to this design that we're working on today. Here's the right-hand side one. Let's turn off the blue. I'm 3D printing this in the other room right now. So the circuit board, like this right-hand side here, this is going to sit in here. These 4 standoffs are going to line up with these 4 screw holes. And there's a notch right here for where the USB-C cable will come in and plug into this. And so as soon as I get the PCB back, hopefully it matches the 3D printed board. I might have to shave off some of the standoffs because I made one mistake and I got things too close to a few of these standoffs. Which one was really bad? I mean, this one's pretty bad right here. So the standoffs I'm printing are 4.5 millimeters radius, right? So that's going to extend into the pad, which is bad because what's sitting on that pad is one of these metal pieces, right? So I'm going to have to shave off like a bit of the plastic on this, like shave off here to make it fit, but that's okay. It's easier to remove plastic than to add plastic, right? So yeah, that's what we're working on. And I'm trying to divide the stream today between some of this 3D modeling for the plastic, the case it's going to sit in, and do some software too. So I'm hoping to work on a bit of my version of what QMK has to the behaviors for mod tap. So a key could either be shift or F depending on how long you press it down. If you this is a tap where you don't hold it down long enough, and then it's like a quick press and release, it's an F, but if you hold it down, it becomes shift. So I want to add that to the firmware today. What you see blinking on the camera too here is the prototype intermediate keyboard where I worked out a lot of my bugs hardware-wise. It's just got 12 keys instead of 36, and it's got a lot simpler shape, and it doesn't have a plastic case. But we did work on these plastic switch holders. So if I show you really close, you can see that there's like a plastic plate that rests above the circuit board and kind of grips all of the 6 switches on each side, right? So it's got that, but it doesn't have the plastic plate it sits in because I didn't design through holes in this prototype board. But I'm going to be using the same controller boards. So those controller boards are just off-the-shelf KB2040s, which use the RP2040 microcontroller from Raspberry Pi. And a lot of the code in the firmware is based on the board support package for the Adafruit KB2040, which also depends on the, it's not showing up here, but the RP2040 board support package, 2040 HAL, hardware abstraction layer. I guess it's right here. If I click on this, it's RP2040 HAL, right? So a lot of stuff I didn't have to write because it's in those board support package crates that we're reusing. So let me know if you have any questions. I'm just working on the left-hand side 3D plastic case. I'm not going to worry about that corner. Actually, maybe I am going to worry about that corner. Can I just, like, not sharpen this? So make that not as sharp, maybe? Yeah, that's better. That's good enough, right? Okay, so then I did this nice curve. We bent these a little bit, so I just need another curve over here, right? So let me try to do the same thing without messing things up this time. Let's save. So add curve Bezier, and I don't know where it is. Where did it go? It's way over there. So move it over here. Move it to -2. Move it roughly into place. Okay. Let's get my camera centered again. All right. So grab that. So roughly the middle of the curve is here, and then we're going to edit mode. Okay, I need to grab this one and put it like, I don't see where the wall is. There it is. Kind of put it right around there where it's going to start to bend, and rotate it so that the curve is the correct direction, and then grab this guy and move him, put him on the other end. So over where this wall is. Very roughly speaking. Right? What am I looking at here? At the bottom? Okay. Oh, hold on. This curve is in the wrong spot. It's got to go at 2, not -2. There we go. It's got to be aligned by the top. There we go. Or it doesn't have to be, but that was the way I was doing it before. Okay, so that looks good. This one looks good as well. All right. Just getting the control points to point the correct direction here. And then grabbing it and just making the... Oh, I just want to grab that one. So making it like as curvy as I want it to be. So how about like that? Yeah, it's good enough, right? All right, so then we do object, convert to mesh. Oop, I did the convert to the wrong thing. Convert to mesh. There's the control points to select all. Extrude down to -6. And then select them all again, and then extrude out to the edge of the wall. So like, I don't know. Let's try that again. So like it's poking through on both walls. It's probably a much better way to do this that I don't know, but that's okay. There, that's close enough, right? And then the idea is we want to then combine those two objects and then delete these extra points here. So let's just dissolve vertices. Okay, that's okay. We'll reform that wall. And the floor too. We'll fix the floor in a minute. Yeah. Okay, so let's hide this guy. All right, so let's just connect things again. So inner wall, top, bottom. Whoops, what happened to the point on the bottom? Let's not connect that. Yeah, let's not connect that. Let's do the very bottom. Oh, I joined the wrong point there. Yeah, I need to cut these, don't I? So let's cut. That cut needs to be at -4. There. Because the inner wall is shorter. The outer wall is taller. Okay. The outer wall is taller. All right. And then let's do this side here. That's fine. Let's do the top. Let's do the inner wall. And then the top. Again, probably much better, easier way to do this, but that's okay. Hey there, Owen Codes. How are you doing? And then I'll just fix the bottom in a little bit. So, yeah, let's do the inner area. So that's all of these points joined together to form a face, right? Let's just grab them all. This one, and then I guess it's just this one and that one. Yep. Then that, these over here. These over here. Okay, then hit, oh, there's a couple more. When you have them all selected, you hit F and it forms that face, right? Now let's do the bottom. Let's make a face here. And then let's make a face here. I can't see which I'm joining to there. A lot of my time doing Blender is just getting the camera pointed right. I think it's that one. There we go. So then I just need to get, now I have that outer wall. Now I just need to join the bottom. So all these points along the bottom. Click, 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 click. What are you making? I'm making the case for a keyboard that I'm making. I did the intro a little bit ago. I'll do it again in a second. I had to just record the intro and like have a link so people can watch it real quick. So this is stream 20. We're really deep into it. I'm like getting close to the end of the project where I'm making my own keyboard. So there's the bottom of it. Okay, so intro again. You can kind of see the middle prototype here in front of me. This is a 12-key keyboard that I made basically from scratch. And a lot of it was the software that's running on these microcontrollers. So it's a Raspberry Pi microcontroller and USB-C connector between them and 6 key switches on each side, right? So after I got that working and the firmware working far enough, I made what you can see printed out underneath, which is the full-size keyboard. So this is kind of like inspired by the Korn keyboard. It's 36 keys. So you get like 3 rows and 5 columns on each hand and then 3 thumb keys. The idea is there's a reduced number of keys. So to get like numbers or symbols, you would hold down different combinations of the thumb keys, and then the other 30 keys become like, they go between letters and numbers and symbols and function keys depending on what thumb keys you hold down. So I designed all of this keyboard, this schematic. I put the names of some people who helped me in chat. I put my name on it. It's the Rusty keyboard. And I'm having this circuit board built. I sent it off to JLC PCB to build it for me. I get minimum order from them is 5 boards. So I get 5 of these. So that means I can screw it up 4 times as long as I get one that's good. So this is what's going to look like populated. So these are like where we can, kind of like what I have on the proto board here, these controllers, I don't have to like waste one, waste any. I basically unplug it from this proto board and plug it in here. And here's some USB-C connectors. It prints out with the two halves connected, but then we break along these dotted lines to break them apart. And then we have 36 of these switches, which are basically three things combined. There's this socket which you plug the Cherry MX hot swappable switch into, and then the keep cap goes on that, and then there's a diode, and then there's an LED, smart LED. And then in addition to that, we have 4 underglow LEDs and then 4 through holes, which are gonna rest, and then have screws go through them to rest in the case. And the case is 3D printed and kind of looks like this if I can zoom in on it. I'm actually printing that, and it should be around about done now. If I can, I'll take a break in the stream and go grab it and show it on the camera if it worked. So this is the case that this right-hand side will fit in, right? So these 4 screw holes are going to rest on top of these headers, or these standoffs, and screws will go in from the top and hold the board in place. And this little notch on the left-hand side here is where you plug the USB cable, and that connects the two halves together. So I'm printing that, and then I'm getting the left-hand side ready to print as well. So most of this work was getting these curves to fit around this thing here. If I were to hide the this one. So this is basically an export of this, right? It's the same shape, and then import it into Blender so I can see where the holes need to be and where the edge of the board is. And then it's like, okay, well, we want the board to fit comfortably in here with a good margin, like 3 or 4 millimeters on all sides. And yeah, I've just been modeling that so I can print it later. I need to actually I actually have them here. Yeah, they're already in there. We don't need to see that anymore, right? Hold on. We just need to make sure that these holes are lined up, and I think they are. Yeah, so then we can hide that, and we can see our standoffs there. I just need to make sure, they look, the left and right look the same. I think I scaled these up before. I need to do the ones on the left. I need to scale them up as well. So let me fix this. So that sits at 0. What about these? Yeah, these don't. So, oh, they're not centered correctly. That's what it is. So what's the position of that? -3, -6. Oh, right, because I need to do a right-click, set origin to center of mass, and then type in -3. There we go. I need to do that for all 4 standoffs. So right-click, do set origin, center of mass, type in -3 for the Z coordinate. All right, and 2 more times. Set origin, center of mass, -3, and then right-click, set origin, center of mass, -3. Cool. All right, getting there, right? I need to put the notch in that was in the right-hand side. So if I remember right, what I did to do the notch was I measured here, and I made sure it was like 14 millimeters from here to here. Yeah, roughly. So that's easy to see because it's where our bend is here. Like, basically it lines up with that hole, right? Actually, it doesn't exactly. It's interesting. It's beyond that hole, right? About 3.5 millimeters beyond it. Okay, so it's this point here, I think. So here's where I want the notch to go, and I want it to go 14 millimeters. So what I'm going to do is I'm going to add a cube, mesh cube, grab it, and put it roughly here. Put it down at, well, let's say it's 8 millimeters tall, right? Positioned at 0. Actually needs to be at -2. Yeah, so now it's on the same level as our board. And actually, let me check here something. How high up is that point? Right there. That's -2. Okay, so it's 4 we were cutting out 4 millimeters of the board, the top 4 millimeters, right? So then if it's 8 millimeters tall, that means I just want to lift this up by 4 millimeters, right? Right, so then let's center it again. All right. I mean, I can just eyeball this, right? If I want the corner to be there, a little bit to the left. That's pretty close. Okay, so this trick I learned is, if I did this right, I make it exactly 14 millimeters by 14 millimeters. Then I drag it to cut across that, right? Then I go to this guy and I add a modifier. It's called a Boolean modifier, difference object, and then I just pick that cube 01, right? And then apply. Control A. And then I can grab that and move it away. And look, I got a notch now. Look at that. There's my notch. 14 millimeter wide notch. So I don't need my cutter anymore. I can just delete it. There we go. I got the left-hand side board done. Yeah, we're 3D printing this. Let me go grab the thing off the printer. Hopefully this is done and I can show it on camera. So I'll be right back. Cross my fingers that it worked. Hey chat. Guess what? Look at that. It printed out wonderfully. I have a case for a board I don't have made yet. So this is this guy over here. So hopefully I got it correct. It looks really nice. So we have the notch right here for the USB. We have the 4 standoff holes. I printed it in like semi-translucent plastic. It feels really nice. Okay, I like it. So now I just need to print. Oh, hold on. One thing I need to make sure is each of these inserts has to fit a nickel insert, kind of like this guy. So I'll bring that closer to the camera. There was my prototype, and the prototype has a nickel insert so I can insert a screw. Let me take the screw out to show you. So you see that copper looking thing? It's hard to get the camera to focus, but that's a nickel plated insert. So I have a bag of those, and what the insert is, it's threaded so that you can screw in a screw. An M2 screw can be screwed into that now. So that's the idea, is that these holes we're going to put an insert into. The PCB goes on top, we insert the M2 threaded screws through there, and it screws on tight. Hey there, Meme Clear Bams. So let me turn off my camera so I can reach behind me and get those inserts. Alright. Had them right behind me. So this is them. It's just a bag of these nickel-plated inserts. Let's see, a moment of truth, right? Let's see if the inserts go into these standoffs. I will need to shave some plastic off of these inserts because of the bug I talked about earlier, which is over here. Because these are printed 9 millimeters wide, right? Problem is I didn't account for that here. 9 millimeters would put the edge right around here, and so like the plastic goes out to here. Problem with that is, coming back to the 3D viewer, if we have the plastic butts up right against the circuit board, right? Well, right there is the little metal part of the socket. So I'm going to have to like cut off a little bit of the, like a little notch on some of these standoffs. So there's going to be like, so the plastic will kind of come down here, and then I'll have to cut out a notch, and then it'll continue to go around. So Rev B of the board would be to move to have like a standoff 9mm diameter standoff, or keep out area, a 9mm keep out area that doesn't intersect anything, any pads or any sockets or anything. So I'm just gonna, like for Rev A, I'm just gonna cut off, probably shave off with a knife little notches as necessary. Okay, here we go. These inserts actually go in. Let's see. Oh, actually, it fits in too well. That's not good. It's gotta like. Okay, yeah, they're too wide. So what do I do about that? Does that mean I have to print it again with a narrower hole definition? Yeah, they're just falling right out. Okay. I can do that. I can make them slightly smaller and print it again. It just takes an hour and a half and a lot of my plastic. But hey, plastic's cheap, right? You know what I can do? I can melt the plastic with a heat gun, right? So these, it's kind of hard to see, but these are fitting in like with too much gap, so they're falling right out. Glue it. That's not a bad idea. MVD dev. Just seat him in there with glue. With this prototype one, I didn't need to do that for some reason. It was a very tight fit, but I think it's because it was this black plastic, and also I think printing a small board like this and a large board like this, you get different results. See, I just glue it in there. Like, carefully coat the outside of these things with glue and then put them in. Yeah, right now they're just really loose. All right, let me not lose these. I'll put it back in the bag. So I should probably just print the other side to match this one, right? And just have that going while I'm working. Glued or epoxied, either one. Right size for the M3 screw? I don't want to change the screw. I already bought the screws. I have M2 by 10 screws I'm going to use with this. I don't know. I think it's neat that the print turned out so well. The bottom's a little weird. I wonder if I have the Z calibrated right. Nothing a heat gun can't solve, right? Melt the plastic a little bit. Yeah, anyway. I'm almost done with this. I might as well just go the rest of the way, right? And take this one. So I'm going to save, and what I'm going to do is I'm going to merge. Actually, I'm going to rename this to standoff left.001, standoff right left.002, standoff left.003, standoff left.004, and let me, on the right ones, let me put a -R. Sorry for the really tiny font. I'm just naming my objects standoff left and right. Okay, so then save this. So then I'm going to take the 4 standoffs and the base, and that's the wrong base. Oh, this should be like base right. And the other one here actually belongs to this collection, and that's base left. Okay, so then the standoffs for the left and the base left, we're going to join them. And then we're going to temporarily delete everything else. And then I'm going to do File, export to STL. We're going to call it base left. Export to STL. And then I'm going to undo till I get everything back. And hit save again. Okay, and then in my slicer, which is here, I'm going to delete all, add base left. And then there's a scaling issue. It prints really teeny tiny, and I hit this every once in a while where I have to increase it by 100-fold, and then it's the correct size. So that's what it's going to look like on printing. And let's look at the layers. That doesn't look right, does it? Is it missing some surfaces? Wait. Oh, hold on. There's some geometry missing. Oh, I probably have the normals wrong. Okay, let's fix that. We have to do view face orientation. Yeah, look at that. I got some... Oops. How'd that happen? I got some faces inverted. Edit. Select faces. Mesh. Normals flip. Okay. And then the one on the bottom. Mesh normals flip. So that's enough to screw up the STL. Is to just have the 3 faces have the wrong normals. Okay, so then we can turn off face orientation. Okay, save. And let's do the same thing again. So take the 4 standoffs and the base and oh, I have to be in object mode. And join them and then delete everything else. So they don't get exported, and export to STL, base left export, and then undo. All right. Unmerge standoffs. Okay. Delete all, add base left. Select it, scale by 100-fold, 10,000%. Well, there are 48 errors in the manifold. Oh, I forgot about that. Well, the slicer fixed it. Oh, no, it's still wrong. Okay, so I forgot to do the fix up in this thing anyway. That's probably what I did wrong. So select all, mesh, clean up, merge by distance, mesh, clean up, what is it, delete loose? That didn't remove anything. Do I have holes in there somewhere? I just don't see them. Oh, wait, what's that? Wait, what? That's not missing geometry, is it? What am I seeing there? X-ray. Faces. No, there are faces there. What's wrong with the manifold here? Who are using to print the PCB? JLC PCB. Am I abnormal? I mean, maybe. What's going on with this weird I bet it's these weird edges that we have, right? Turn off X-ray. Show me all. I mean, maybe it's these weird edges. So let's just collapse these or dissolve the, not the vertices. I want to dissolve the edges. Yeah, I think it might just be these extra edges on the board. We don't need them anyway, right? Let's just dissolve them all. Need that edge. But these inner edges we don't need. So X dissolve edges. Okay, why didn't it want to dissolve that one? Okay, I don't understand. Oh, we have a problem. Missing face? Then what is that face there? Let's delete that one. Let's add the face that should be there. And I should have this color thing on while I'm doing this. Yeah, okay, it's the correct orientation. All right. All right, well, let's continue to dissolve edges we don't want. So, I don't need any of these. And I do need those edges, right? Let's look for edges I don't need. How about these up here? Recenter my camera so I don't go insane. All right. Yeah, like these edges here. I don't need these. Dissolve them. This edge doesn't need to be here. All right, what else? That edge. And all these edges down here, right? X dissolve. Okay. I don't need these edges either, do I? Yeah, these edges don't matter. Dissolve them. Why do I need those? I don't know. I shouldn't need any of these. Doot, 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 doot. X dissolve. I wonder why it thinks it needs all of those corner edges. I wonder if that's the problem, like these, maybe these aren't actually joined properly, these corners that I made. That's probably it. I probably haven't joined the geometry properly, right? Alright, we'll fix it. Fix it so we can print it, right? Dissolve those edges. Okay, we shouldn't need these. Why does it insists on having that for some reason? Don't know why. My normals were abnormal? Yeah, maybe. Okay. There's something about the join that I did there it's wrong. So, X-ray mode. Faces. Oh, is there no top face there now? Did I delete that by accident? Hold on. No, we see that there's a face there. Okay, it's just hard to select. You have to turn off X-ray mode to see it. Where's the center of that face? There's no dot for it, really. Okay, anyway. Oh, there's some kind of weird internal face there. X dissolve face. It doesn't want to. Why not? Well, that's weird. Oh, we don't need any of these faces, right? Yeah, we don't need those. That's maybe why I couldn't dissolve that edge. We couldn't dissolve these vertices, right? Okay, and then this edge, dissolve it, please. Can't. Why not? Okay, there's weird stuff going on inside here. Did I delete the bottom or something? I don't know what I did. There are faces in the interior. Yeah, we want to delete those interior faces. I don't know how though. There's one. Can I just delete the face? Okay, I guess it did. I guess I don't want to dissolve, I just want to delete. Now what the heck is that? That's some kind of weird abnormality. Let's just delete it. And then can I just now dissolve that edge? Okay, cool. I think I fixed it. So now I could probably dissolve these edges too. Yeah, look at that. Nope, there's still something going on there. These are X-ray glasses. What do we see? There's some kind of... It's not a face, is it? There is a face there. Delete the face. Cool. And hopefully that didn't mess anything up. Alright, so then dissolve the edge. Neat. I think I fixed it. Alright. And then there's probably something here too, right? Alright. An interior face, yes. So delete that interior face. See, I'm just I'm very new at Blender, so I make these mistakes, right? I don't know how to clean things up at first. But I think we're getting there, right? I'm struggling with the camera, that's okay. Let's look for interior faces here. Okay. Trick I found is you zoom out, or zoom out, look down, and then look across. And now we have our camera more or less centered around our area. Okay, so then show me faces. I think those are just edges we can dissolve. So turn off X-ray, go to edge mode. Let's just dissolve these edges. Okay, there is one we can't dissolve. Yeah, so there's something over there. Okay, there's something there and there's something there we need to clean up. So X-ray mode. What do we see there? A face? Yep, there's a face there. Delete the face. And here too. Delete the face. Okay. Did I delete the correct face there? Yeah, okay. Alright, then I can get rid of the edges now. By dissolving, not deleting. Dissolve. Cool. We can get rid of all these, right? No, there's something going on here. There was something going on the other one too, right? Oh, right, there's those little faces there that we need to get rid of. That shouldn't have been added in the first place. These ones don't belong. Yeah. Delete faces. Turn off X-ray. Didn't break anything. Alright, good. Cool. Let's try again. Or actually there's some more edges I need to get rid of. Over here, right? Dissolve away all these edges. Oh, nope, that broke something. Okay, I gotta be careful. What's going on here? Some kind of weird geometry going on? There's an interior face. That's it, right? Now, dissolve edges? Yeah. Cool. Cool, cool, cool. Whoa. Okay, there's something going on there. Oh, I don't want to dissolve those edges. Those are important edges. But what's going on here? There's an extra vertex there. Yep, there's an extra vertex, so dissolve the vertex. Okay, cool. We need to keep those. I don't need this interior vertex though. Cool. All right. We need those edges, right? Because those actually are edges. That's not an edge, so let's dissolve it. All right. I see some extra points we can get rid of. That one, dissolve it. That one, dissolve it. We need all those edges because those form that curve, right? We need all the... Oh, there's an extra one there. Okay, I think it's looking good. So, let's save it. Merge the standoffs with the base. Oh, I have to be in object mode. And then delete. Oh, I missed one. 1, 2, 3, and 4 with the base. Join. Delete everything else so I can export. STL to base left. Then undo. Save. Okay, and then add base left. It didn't complain about having to fix anything, so maybe it worked this time. Scale up by 100 times, and then layers. This looks good. So there's the base. It draws this ring around it, which is nice because it makes sure that the plastic is flowing good. And then here's the base, which is really thick. And then there's the thin part of the base, and then we start to see those standoff holes. And they're now, we're just drawing walls and 4 standoff holes. And then that's where the notch starts. And then the tops of the standoff holes, and then there's just the walls. Cool. So export G code, right? And then we're gonna call it base left. And then I gotta copy it to the printer in the garage and then start printing. Hey there, Panosa. Carson P, huh? Are you sure that the beloved corners are attached to the sides and not a separate object? Whether they are or not, the final test is when we get into the slicer and we see that it looks good. So it's possible that you're right that I don't have them attached, but when it got to the slicer, it looks good. It looks good to me now. There's no like breaks in this that I can see. Like those are walls. There's the notch for the USB. Yeah, it looks good. So I could look more closely. It might have been something I fixed since you wrote that chat message. The bevel corners are attached to the sides and not a separate object. Well, this whole thing is one object, right? All of these vertices are in one object. I'm keeping the standoff separate objects just so that I can more easily move them around. I probably don't need to do that anymore. I could probably keep them merged with the base now. I already fixed it. It's an old message. Okay. Yeah. Yeah, okay, cool. Looking good now, right? So maybe to clean this up and just be done with it, I would I don't need the original PCB mask exported files anymore. Okay, let me at least take the base, the standoffs, and the curve, and let's grab them all to... Oh, that's the wrong standoff. Can I deselect it? There we go. And let's grab them and then put them down here. I kind of feel like I should grab everything and center everything like, I don't know, arbitrarily there. Where's the... Okay, the origins are kind of weird. Let's fix the origins, shall we? So Set origin, center of mass, I guess. Set origin, center of mass. All right. I kind of think they should sit at 0. So what are they sitting at now? At -6. Let's move everything up 6. Select all and then translate up 6. Okay, it's not working so well. Probably because I'm zoomed in. No, I need to be zoomed in. There we go. Now I have fine control over it. Actually, I can just type it here, can't I? Okay, so these should all be at 0. Yeah, close enough, right? So now they're sitting, the bottom is 0. So if I were to look at the top of the standoff, it should be at 8. Or 6, actually, right? Yeah, and the top of this wall should be 8. Which it is. Alright, great. How come the holes look different on the left and the right? Those look gray and then these look black. That's weird. I guess I'm not too concerned about that. We can hide those. I can keep them in there. Oh, looks like I put the notches in the different places. Well, one of these notches is better than the other. I wonder which one's right. I'm not too worried if I get it wrong. It just means I'm gonna have to cut off more plastic. So I think the left one is more correct. Because if the hole is there, it's slightly below where the notch would be. Okay, on the right side, the edge of the notch should go to the edge of the hole. Yeah, I think this one is too far that way, so I might end up cutting some plastic off here. Yeah, I kind of did a bad job on that, didn't I? I should have been more precise in my measurement. Okay, let me get a precise measurement and see what it is. So, measure from like the very bottom of the board to where, so then vertically it's 43 millimeters. Okay, so then like this point down here and this point over here should be 43 away from each other. So that's a y of -53 point. Okay. -53 plus 43 should be -10, right? Okay, so this is like off by 2 millimeters. It needs to go 2 millimeters more that way. So then this other one is probably really wrong then. Okay, 52 and... Yeah, that's really wrong. I think the one I printed, the notch is way too close to the bottom. Actually, I have a paper in front of me. Why am I not just putting it on top and looking at it? I don't know. Actually, that looks like it's actually lined up. Maybe I'm getting confused? So then if the right-hand side is correct, then the left-hand side is not correct, right? Oh, I'm measuring from the... I need to measure from the board cutout, not the... I need to measure from here to here. 43 millimeter. Okay. That makes some more sense. So, -45 plus 43 is -2. So this is 10 millimeters off then, right? Well, wait a minute. That's the wrong direction. Oh, I'm reading the wrong thing. It's 30, not 40. It's 30. Dang it. Okay. I'll get this correct someday. Add 30 to negative 45, you get negative 15, right? So this is 3 millimeters off. It needs to go down by 3 millimeters. All right. Which probably matches up with this one. Yeah, this is closer. This is within a millimeter. Okay, so I have the notch on the left side a little bit too far up, which is good because I haven't printed that one yet. So I need to move this 3 millimeters down. Why don't I just move it to line up with the other guy? So that would mean just cutting out a little bit more, and then I can actually just move these vertices over, right? Along the Y direction, 3 millimeters. Negative 3. I mean, sure. And then what happens if I just move the other 4 also 3? Grab Y, negative 3. Well, then I'm intersecting some other vertices, but then I can just delete them, right? Hold on. What happens if I do select all mesh, clean up, merge by distance, and then increase it slightly? I wanted to merge those, but I think it's a different problem. I think that... Do I just want to dissolve that? No. I think the problem is this needs to be moved a little bit. Okay. Yeah, let me undo a little bit. I think this wall needs to be moved off a little bit. Like negative 0.02. Negative 0.2. Then I can move these by 3. There we go. Now they're much closer together. I don't think I really care about lining them up exactly. I think it's close enough. I think I just want to print it now. So, save. Okay, standoff and base. Join, and then delete the right-hand side stuff for a moment. So I can export to STL. And then export. And then undo a few times. Save. Alright, and then slicer, we're going to delete, add this again. Scale by 10,000%. And then look at the layering. Make sure it looks good still. Looks good to me. Alright, I'm going to export G-code. Base left, right? Yes.
Beep, beep.
Cool. So that's ready to print. Yep, designing a keyboard. Hey there, Reverend. Based off of the Raspberry Pi microcontroller. And I'm writing all the firmware in Rust. So today I mostly, I 3D printed the case for it. I already sent off, I designed and sent off the PCB to be printed. So I did that in some previous episodes. It's inspired by the Korn keyboard, so there are 36 keys total, 3 by 5 on each side, and then 3 thumb buttons. So use the thumb buttons to switch layers because the keys have multifunction. They're either letters, numbers, symbols, etc. These 3D printed cases are what the circuits board is going to sit in. So these 4 holes on each side are through holes that we're going to be able to put screws through to screw it on. And I moved it out of the way, but I made an intermediate prototype, which is only 12 keys, just to test out some ideas. So everything about the controller and the connectors are final. The only thing about these prototypes is they lack the screw holes, and they only have 6 keys on each side instead of 18. So, but I did prove out a lot of concepts, and a lot of the firmware got working on this guy, and I'm going to continue to do firmware development on this until I get the final board. Oh, I'm glad you think it's cool. I think it's cool too. That's why I'm doing it. So this is done now, right? I can check this in and say that, I should start the printer. It takes an hour and a half. Actually, I should probably just print it tomorrow because it's already midnight. And I don't want to stay up waiting for the printer. Adam doesn't stream anymore. Adam is planning to come back to streaming, but not for a few years. Used to watch his Botland streams. Yeah, he Botland is no more, sad to say. And he's now Adam Learns. So it's do I have a shout-out command? I don't think I do. But it's twitch.tv/AdamLearns. And his name is on my PCB. Extra thanks to him and a few other people from chat who helped me out when I was designing the board. Yeah, he's coming back in a few years. Right now he's working for Google. Making the monies. Okay, I'm going to put this aside because I have the G-code file. I just need to send it to the printer. And then I'll have both sides. Let's work on software now. Let me check this stuff in. Slicer, we're done with the slicer. Let's check this in. I want to rename this one base right models. This one should be base right. And this one I want to be named base left. So I got the G codes and the STLs for the base. We don't actually need the blend 1 files. Those are backup files, so let's delete those. Beep, beep. Wait, what happened? It moved my cursor around. Okay, yeah. So we have the base left and right. We have the blender for it. And then I changed the standoff test to test narrower standoffs. I think I'm just going to undo that. So let's just stage these 5. I'm going to undo my standoff change. Yeah, so let's undo that. Beep, beep. Okay, so git commit. So this is a finished first rev of do I call it a case or do I call it a base or what? I guess case base. Keyboard trace, tray base, tray/base, keyboard tray/base. How about that? All right, and then we're gonna push that. Chassis. That's a great name. I should have named it that. Biggest challenge is naming stuff. I know. Hey there. How do you say your name? Wally Wonka. With the 4s. How are you doing? I'm going to do some firmware development now. With the prototype 12 keyboard, I want to work on this concept that QMK has and kind of have the same thing for my keyboard. The concept is that we might have a key like, let's say this one. Right now it's only shift. I would like it to be shift if we hold it down for long enough, like this. But if we just tap it, I want it to be like a letter or something. So right now it's always shift, so we don't see anything unless I press another key. Like this A, this is A. If I hold this one down and press this, it's shift A, right? the other keys on this keyboard are 1, 2, or 2 through 6. So I would like this key to be 1 if we tap it, or shift if we hold it down. So to do that, obviously I need a timer, I need to measure for this tapping term, and I need to like know that we're holding down that key. And then, like it says here, detect when it's released, and if it's released before the tapping term, we want to emulate or simulate a short key. For in this case, it'll be 1. But if it's held down past the tapping term, we want it to activate shift, and then when it's released, we release shift. Scared to use your PC at the moment? It seems stable now. What happened to your PC? You had 3 blue screens of death? I had that while streaming a couple times. It turned out to be the firmware was out of date. I think the solar storm was walking it out. For me, it was the firmware was out of date for the it's not called BIOS anymore, right? It's the firmware for the motherboard. The problem was I had a CPU that was newer than the firmware build on the motherboard. The UFI, right. So I did a UFI firmware update, and that fixed my blue screens. That was like a couple years ago when I first got the computer I'm using now. Okay. The idea I had in my mind to do this was in keyboard over here. Whoops. How come it went? Keyboard here to have some state about what keys are held down at what times, if they are modifier keys or mod tap keys. Actually, will we need to know just in general? Zoom out a bit. Do we need to know in general if something, when something's held down? I don't think so. What do we want to call the memory for this? Like keys held down and when they were pressed. So like active keys maybe? So that would go up here. What active keys would be like probably we probably want a hash map of like a switch number. So what would that be? Like a U size to a time. I think that's U64. So hash map won't exist, right? I'm waiting for the... Oh, maybe hash map does exist. No, it doesn't. We have to import it from... Oh, we don't have standard library. We can't have hash map. This is a no standard library project, right? So we can't use the standard hash map. So is there an alternative to hash map in no standard, maybe? You have a noob question? What's your noob question? I'm going to look for no standard Rust hash map. What's a Boolean? A Boolean is just another word for a bit. So it's a type that has 2 values, on and off, or sometimes it's 1 and 0, true or false. It all means the same thing. Yeah, there are a lot of synonyms. So bool is Boolean, or on off, 0 1, true false. They all mean the same thing. You're planning to learn Rust, so it's difficult to learn. I thought it was difficult to learn Rust, yeah, especially coming from C++. When you learn Rust, you'll be fooled into thinking it's enough like C or C++ that you can code the same way, and then you'll find that there are things like the borrow checker that will get in your way a lot because you're used to doing things that are not memory safe. And Rust is going to kick your butt like it kicked my butt. And that's okay. You'll learn. Hey there, Ramy. How are you doing? You know stuff by weird non-standard names? I mean, so does everybody for certain things, right? Starting to take the shape of an actual keyboard? I know. Look, Ramy. I 3D printed the case for it. Look at that. the PCB for it is fully designed. I shouldn't have closed it because people are going to come in and ask about it, right? It's fully designed. I have Endorn's name along with Adam on there. And I should have put Ramy. Gosh darn it. Picked up the big C in Amsterdam? Really? I didn't pick it up. How did you pick it up when I didn't? I'm sorry to hear that. So yeah, the board is done. The firmware is working, although we're adding hold+tap to it today. This hold+tap stuff from QMK. I want to have the same kind of thing. What would a name for a variable be? All of these are variables. Variables usually have names that correspond to what values mean. So, like, this value means, like, this pin on my board means column 0 for the keys. So you pick names that tell you what the value means. I can add you as a Sharpie to the case. That's true. Actually, I should get your autograph and just on the bottom of the case. Why not? Oh, this is your jam? Oh, I'm glad it is. You meant a value that is 1 to... Oh, that kind of value? Usually it's called an integer. Just like in math. In Rust, it's heavily abbreviated. You'll see like U8 or U64, and that means it's unsigned and 8 bits of an integer. So like in C would be int, or unsigned int. But Rust, we have to pick a definite size, and it's all abbreviated. Our unsigned numerics, the stuff, the standard in Rust, they're just more common. You can have an assigned integer with an I, but a lot of the times you don't need negative numbers. So U8 or U64 is just saying it's an integer, and we don't need negative numbers. So I say it's more common, but we do have the signed variety as well. Get to be specific with number. Yeah, Rust is very, very strict about types. They're not as easily convertible from one another as they are in C or C++. So you have to be explicit. Like even between U8 and U64, you can't just use them interchangeably. You have to convert between them. Yeah, it is very pedantic, but I kind of like pedantic stuff, so it fits me pretty well. Okay, so we have... I need to find an alternative to hash map. That's what I was looking at, right? Here we go. Here's someone who's already run into the problem. This is why Stack Overflow is great. Working on a project meant to be compiled to a no standard. How do we use these types? Okay, they're telling you you don't need to restrict it to no standard. Okay, there is the vec and alloc crate, but we don't have hash map. You can't use hash map because to avoid hash collision attack need to be access to secure source of random data. Is that really why? So we don't have a random? Okay, we can use btree map then. Okay, let's use btree map. Btree map. It says it's from the alloc crate, which we do have access to. Perfect. Now we have a btree map. We just need to initialize it down here, right? So active keys is btree map new. Cool. Then is there a third one? Well, there are like various like types of integers that are slightly different in some ways. Like there's the non-zero integer in Rust, right? What's it called? Non-zero. Yeah, there's the non-zero, like non-zero U32 means it's a 32-bit unsigned integer that can't be 0. But yeah, Rust has like a lot of types. And C and C++ have a lot fewer types, but those types are more flexible. Thinking about overflows in games, yeah. So Rust protects against overflows, and that's why you need a lot of elaborate types, because sometimes like you want it to not only types but functions, because sometimes you want it to overflow. So there's like the overflowing add, for example, will let you overflow on purpose. And let's say you don't want to overflow, you just use the normal add, and then if it does overflow, you get a panic or a crash. Or let's say you want the saturating add. So that will like add up to the maximum and then just stay at the maximum. So there's a lot more pedantic stuff in Rust, and a lot more. You have to be more precise, telling the writing code that says what you intend. So do you intend to saturate, to overflow, or never overflow? The way you add is different. Okay, I think let's fix this warning. Is it just saying we never use it? Yeah. So let's use it in our scanning code. What we'll do, I think, in key. I know what I need to do. I need to refactor this, because this key codes add we do like 6 different times. I need to have it go through one function. That's true. Rust is about safety, about memory safety, and being pedantic helps keep it safe. By the way, if you're wondering what this code does, it all harkens back to the schematic for the board, and this is a normal thing for keyboards these days. So on the 18 keys on each split side, we divide it into 3 rows with 6 columns, right? And I say 6 because even though there are only 5 columns, I treat the thumb keys as a column, right? So we divide them in that way, and the trick is that each row of keys shares the left-hand pin, right? They're all connected together. Every column connects. For all the keys in a column have a common right-hand pin. There's a diode added here to solve a problem called ghosting. I'm not even going to get into that, but just pretend this diode isn't here. The columns connect the right pins of all the keys in the column, and the rows connect the left-hand pins. So the way it works is we normally drive all the rows high to a 1 or true state, and the columns are all inputs, right? One by one, we'll drive one of these rows at a time low, and then we'll read in the columns and see which of those goes low. So basically, if you aren't pressing any keys, the columns all stay pulled high, right? We weakly pull them high. But let's say you're pressing switch 1. Now when you drive row 0 low, because you have the switch held down, there's an electrical connection between the left and right pins, and so the signal from the row 0, which is low, ends up being read back on column 0, but not column 1, because you're not pressing switch 4. So you'd read column 0 low, column 1 high, and say, okay, it must be switch 1 because we're driving row 0 low. So then you drive that one high, and you drive row 1 low, and if you still see column 0 low, it means you're also pressing switch 2. So 10,000 times per second, my code is driving each of the rows low one at a time and reading the columns. Actually, for the prototype, we had rows and columns swapped. So in the code, you'll see we're driving the columns low and reading the rows. But it doesn't really matter. It's terminology. It's the way I wired the PCB. On the final design, I'll be swapping the rows and columns. We're driving something low and reading the other dimension, right, to see which keys are held down. So on the proto board, I only had 2 columns. So we're driving column 0 and then driving column 1. And then we're reading the 3 rows, right? So we either get our shift thing that we're going to work on today, or we get the one above it, or the one above that. And then it's column 1, we'll either see the bottom key, the middle key, or the top key. And I'm just taking this base and adding a number from 0 to 5 to it, and then the base depends on if it's the left hand or right hand side, and 4 is the scan code on USB for A. So that's the right-hand side, the one that receives the greeting, and 30 is the base for the number 1. So if I hit 2, 3, 4, 5, 6, or A, B, C, D, E, F, 1 I can't press because right now it's a shift key instead of 1. But we're gonna hopefully change that. Only 10,000 times per second. Yeah. Well, sometimes it's faster. We're doing it as fast as we can actually. Is the capacity of the diode already enough to debounce your keys? I've seen some bouncing, so I have on my list of things to do. I will probably want to address to debounce the keys. But with this prototype, actually, I haven't seen it as much. It was the breadboard that we were using before that I had these PCBs printed, where we were seeing a lot of bounces. And not so much now. I might be able to get away without debouncing. I mean, we could put in debouncing code anyway. So anybody who's wondering what debouncing is, when you press a key, if you're sampling it a lot of times per second, you might actually see right on the edge between when the key's pressed and when it's not, you might see it pressed, not pressed, and then immediately pressed again because of the transition. And that's called a bounce. Like, electrically the signal was right on the edge and then kind of dipped over briefly, and it looked like there was 2 presses, one very fast and then the other one that's the normal press. So debouncing usually is you have to see a stable transition. It has to go from not pressed to pressed and stay there for like, I don't know, 100 microseconds is probably enough, right? Anything shorter than that is probably a bounce and you can ignore it. Okay. I think I do want to refactor this code because every time we would do an add, I also want to do a registering it in the map. So what if I just take this and refactor it out? Extract function. We're going to call this, oh, it didn't put it in the right place either. We're going to call it, register key down. Okay, and then I have to add the key, which is going to be a U size. And I also want to move this into keyboard, so let's grab it and paste it somewhere here. G comes after F, right? So it should go there, and then we'll have mute self. Okay, and then that means I have to actually borrow self here, and then we need to add the key, which is, in this case, it's going to be 0 for key 1, right? Oh, I got this wrong. It's self dot. And I can't type because I'm back on QWERTY and I've been using my my Colmac keyboard all day. Okay, so then this is going to be 2, right? Yes. And then this will be 4. And then this will be 1. And this will be 3. And then this will be 5. Okay, and then here I want to add base plus key. Okay, now here's an example where we can't add a U8 to a U size, so I think what I'm just going to do is say base plus key as U8, or U8, can I just do an as? Actually, why am I using a U size? Can't I just make it a U8 and make this cheaper? Let's just make it a U8. We're never going to have more than 255 keys on our keyboard, right? So that means this becomes a U8. All right. Big part of that, a lot more, is not using memory that the program isn't allowed to. That's generally handled at the OS level, except in embedded. Yeah, we have no OS in our case. Although I'm pulling in certain aspects of the OS, like a heap. We're just managing it ourselves, hard-coded from RAM that ends at a certain address and begins wherever the linker tells us to start it from. So we have the alloc crate because of that, but I have no standard library because we have no file system or any system calls or any underlying kernel. So yeah. Hey there, Stripe Monkey. Stripe Monkey was helping out a bit the other day, so they got their name on the silk screen of my board. Look at that. Okay, moving on. I think I want to put this code into here for now. And then this goes there. Right. We only want to do this for key 0, right? So if receive greeting or key is not equal to 0. Oh, we have to put in the modifier. So hold on. It should really be modifiers, right? Yeah. I'm gonna have to do a lot of changes here. How come my, is it alt-click? Yeah, alt-click is what I should be doing. Okay, let's go back to modifier. Let's rename this and put an S on the end. All right. Cool. Then what's the error here? S. And this needs to be dereferenced. Okay, so then I can remove this part. Just do that. So right now it's just hard-coded that I really want to turn this around too, right? Let's say its key is 0 and we haven't received a greeting, which means we're the left-hand side keyboard. And then this is the shift function. Whoops. Yeah. So we've hard-coded our shift key to be key 0 if we're on the... This is a... I should fix that, shouldn't I? I'll fix it later. What I wanted to say is something like self side equals left. Side left. That's what I wanted to say. But I'll do that later. Right now we know we're the left sideboard if we haven't received a greeting, because the greeting is always sent from the one connected to the computer to the other one. He sends the greeting, he receives it. So if you receive the greeting, you're the right-hand side one, and you're not going to have the shift key. It gets complicated because both of these boards have the same firmware. So what these keys mean depends on which side we're on. And right now they determine which side they're on based off of who's connected to the computer and who's not. Hold on a sec. Gotta hydrate. Okay. So now in addition to doing all this stuff, we also want to say self.activekeys.insert key, and then we need to get a time. I guess that would be self.timer.getCounter. Yes. So that registers the exact time in which we press the key, right? So now we have to have code that detects if the key is not pressed. So I guess what we can do is we can have else's here, right? Something like self dot register key up. And I guess we do want modifiers, right? No, not necessarily. I think we just need to know the key number. Yeah. So we're gonna copy this around. And I already see myself refactoring this a bit because I have the key code copied, right? Yeah. I don't know, I feel like it's been a while since I've done software. I've been doing the board design for the last week. Does Rust also do object-oriented programming? It does object-oriented programming. Yeah, Stripe Monkey is correct. It's not object-oriented programming, although it does have a few things that support object-oriented programming, like trait objects. So you can define a trait in Rust that's kind of like an interface or a pure virtual base class in C++. And then a trait object is a value whose type has been erased, but along with where it is in memory, you also have a pointer to a vtable, just like in C++. And the entries of the vtable are the implementation of the trait for that type. So it's basically you can pass around the reference to an object to things that don't need to know the concrete type, but they only need to know what trait it implements. And just like in C++, you call its methods through a vtable. So that's one of the core principles of object-oriented programming, right? Is that you can define an interface and then have many different implementations of it, and then you can have a function that can accept any object that implements that interface. And mechanically, you usually do that through a function pointer table. And so Rust supports that through trait objects, just like C++ would support it through the inheriting through inheritance, basically. Okay, so yeah, let's just do the register key up. That would go after key down. And we only need to have the key. And it's basically going to self-active keys dot erase or remove key. What's wrong with key? Consider borrowing. Sure. Because you don't need to consume the value, even though it's a simple type. So I think I ought to combine these two, right? So an easy way to do this would be what is the type of this? It's option. Oh, it's a result bool. Well, actually, all of this is the same, right? So really all we need to pass is a pin, a borrowed pin, and a key number. So what would that look like? Register key or something? How about just scan key? So this would be like let key row and this would be like row. And then we need the key codes, the modifiers, the base, and we need the key. And key goes here and here. And then we need... Okay, so if this is only used once, I can just put it there. Yeah, but I need row. And here's where it gets interesting, right? Because it's going to be a generic based off of the row type. Because where we use it is down here, and these things are pins of certain types, so it's going to be a generic on pin of something. Wait. Pin is not a... Pin is a struct. Oh, yeah, so it really goes here. I don't know. We just put T when we don't know what to put. Okay, yeah, we have to say that it's one of these, right? Hal? Is this thing imported? Pin ID? Is GPIO imported? No. I mean, I guess I can keep it at the, this full name. I don't know, can I do Hal? No. Just leave it the way it is. Okay, so these are already borrowed, so I don't need to borrow them again, right? Just do that. Okay, and then I can just say scan key down here where I do all this stuff. So self.scan key, self.row, well, borrow self.row 0. This has to be mutable, so does this one. Base and 0. So that replaces all that code, right? Cannot borrow mutuals also... Wait. Oh, shoot. That's a problem. How is this normally solved? Then we have advice on good place to start with Rust. Yeah. Go to your search engine and you type learn Rust. So here's the site you want to start with. You can either read a book, you can do like a tutorial online, or you can look at actually example code. So people learn in different ways, so pick the way that you learn the best or that's most fun. And they have different books depending on if you want to look at the oh, what was I going to say? Oh, this is the core documentation, sorry. You start with the book, and then once you've read through the book, then there's other books to like sharpen your knowledge in specific areas. And then they have like different domains, so like WebAssembly, embedded, and they have like the Rustonomicon for like the really nitty-gritty details. The unstable book, there's a reference. So yeah, I would start there. Rustling exercises, yeah. Okay, I can't, if I'm borrowing that, yeah, I can't just do this, can I? Let me think about this. I suppose we're really doing two things. We're borrowing key 3, and then we're tossing key 3 once we've made the decision. So really it should be like self scan, well, self register key. And then here it's self scan key self row 1. Right? So let's fix these up. Basically breaking this into 2. Register key does, so this is like if key down. So we don't use row anymore, we just have key down is bool. And then scan key doesn't need any of these things. And it doesn't need to mutate self. It's basically, it would say matches, right? Row is low. Okay, true. And then this returns bool. Do away with all that. I think that would work. Yeah, except for what's wrong here. Can infer type for what? Oh, right, because this doesn't need to be generic anymore. Yeah, okay. That's what we want. It's too bad that it can't all fit on one line, because that would be cool. That's what I kind of wanted, but that's okay. This is going to be replaced by an iterator eventually anyway, because we're going to have basically a collection of keys and what their scan codes go to, right? So, like row... Oh, did I mess this up? This should have been a 0, right? Row 0, 1. So row 0 is key 0, row 1 is key 2, and then row 2 is key 4 for column 0, right? Yes. Am I doing this right? Yeah, I think so. And then we copy this, right? To do the other column. So all this gets replaced with 1, 3, and 5. Cool. And so now we have everything going through here, whether it's down or up. So then we can make, like, for the decision of like key down right now, if it's the this key right here, we are turning on shift. But what I can do instead is have it do nothing and have it be based off of the timer or the key up, if it is that key. So I kind of want to do this then, right? So, oh, what am I doing? Not here. Down here, right? We're going to say, like, if I should probably do it like if it was an active key, then it's a tap. Otherwise, should I mark it? Hold on. Do I need to track that it's still active if we've already made a decision that it's a mod. Let's see. Did I close it? No, it's over here. Do like a modulo counter. Well, what we need to do is we're going to have a timer. We're sample the time at the beginning, and we need to sample the time when it's released to see, like, was it held long enough? If not, then we need to this is the second part. I'm going to have to do key press simulation where we put the key down and then we set another timer to then report that the key is no longer down after some short amount of time, like, I don't know, 5 milliseconds or something. And if it is held on long enough, then at the timer expiration, we want to assert shift. And then when the key is released, then we release the shift. Yeah, then that means we do need to track when it's active, because when it's released here, we want to simulate a key press. And when it's released here, we want to deactivate shift. Yeah, that's okay. That happens. I'm not explaining everything. I'm kind of, what I'm really doing is, as I'm working, I'm just saying out loud what I'm thinking. So I might not be thinking about a lot of the background information. I'm just kind of focused on the changes I'm making right now. And it might not make sense if you weren't here to see all the code written from the beginning. So I'm basically hard coding which key is mod tap right now. But what are the decision points? Decision points is basically when we release the key and also if the timer expires. So let's do the release the key first. Yeah, so if we release the key and it was our mod tap key, then we need to see how much time has elapsed. So if self.timer.get counter minus, well, I need to get it out of here, right? So if let sum, actually we can remove it and get it out at the same time, right? Why don't I just do it this way? If let sum interval downtime equals self, actually I can just do this, right? That's how it works. And this is downtime is let's say greater than or equal to, let's just hard code it right now. I think it's in microseconds, but I probably want to confirm that. Let's see, what does get counter say? Get the counter value. But what units is it? I think it's in microseconds, but I'm not quite sure. Okay, here we go. Microseconds, right? Oh, there's a generic. Oh, right, because we could express it in other units, but it gets put into microseconds and compared with, yeah, so I think it's in microseconds. So 250,000 microseconds, then it will be treated as, then we will just deassert shift, right? Else we're going to simulate a key. That makes me think I should have like another map called simulated keys. Yeah, so let's imagine we have a simulated keys. And then here we'll insert key and the current time. Actually, we could just sample the current time here. Let now equal that, and then we can just say now here. And we can put now here. So this doesn't exist yet, but it will soon. Okay, so here's where we want to, like, clear the modifier. So that means I'm going to want to have modifiers, right? That means I'm going to want modifiers to persist between scans, right? Yeah, I think so. So that means it won't be in an argument at all. It'll be self, right? So it'll be self.modifiers. and equal the inverse of 2. Okay, and then that means there's no modifiers here either. It's self.modifiers. So I need to, let's just add it now. Modifiers. U8. Okay, and then down here, modifiers 0. Hey, this is out of order. How did that happen? Let's fix that. That should go there. I like to keep these in order if I can. Oops, wrong key hit. Where am I? I don't know. Here I am. Control X, Control V. Okay. Right, so there's no modifiers here either, and we don't need that. Okay, and then down here, don't have simulated keys yet. Actually, this might fit then, right? So if we delete all these modifier lines, maybe it goes back to one line and we're happy. Oh, look at that. I like it. We made the line fit. All right, we can actually read it again. Okay, so then we don't want this modifiers. So here it'll be self.modifiers. Oh, that also means, actually, this keyboard report, is that what we compare to see if it changed? Yeah, we're always replacing it. Hold on, when do we... blah, 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 blah. What am I looking for? Right here, I guess. Wait a minute, why is this always replacing it? Oh, I didn't know I was doing that. So every time we scan, we're generating a new keyboard report, and then we're always sending it. I guess what happens is it replaces the old one from the from that we sent before, right? So if the host, if we do this like 100 times, only the last one gets kept, right? Let's see what this says. Tries to write an input report by serializing the given report structure. Buffer overflow errors returns the serialized report is greater than 64. Okay, but what does it do if we've already written one? Blah, 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 blah. I don't know what this does. It's going to take our R and do something with it, right? Where? Okay, I guess it happens down here. Serialize to the endpoint? Huh. Okay. Oh, endpoint, right, here it is. Writes a single packet of data to the specified endpoint and returns the number of bytes actually written. The buffer must not be longer. Okay, bus write. The reason for short write is the color passes slight. So I'm like, what happens if the host doesn't read it? Do we overwrite it? I guess we get a wood block, right? Previously written packet is still pending to be sent. I'm just wondering, like, why did I choose to, like, always do this, even if the keys didn't change, right? If the report didn't change, why are we sending it? I don't remember why. Okay, wait. Okay, I gotta revisit this. I don't think we want to do that unless something actually changed. This report, it's in key codes. Don't I want to put the modifiers into that? Well, okay, I'll worry about that later. Let me put a note for that. Areas that need work. I guess it is a system stuff, so this would be revisit. Should we be writing a keyboard report every time we scan, or only if something changes? There's no reason for this to be so wide too, right? I can make that shorter so this will fit this window. There. Okay. Revisit that later. So right now we're just always going to overwrite it. We're getting it from self modifiers. Okay, so then so here's where we turn shift on, and there's where we turn it off. I don't have simulated keys yet, but let me at least get the shift done. So the decision on whether it's a shift or not is actually not until the tapping term. So that means I can't. So actually, right when this happens, we want to start the tapping term, the timer. Okay, we're doing that here, I guess. We can just, I know what I can do. So, I guess turn this logic around and do that. And just don't do that. Okay, and then, yeah, after doing all this scanning stuff, we want to see if the tapping term is expired. Okay, so we'll just do let now equals self.timer get counter, and then if let some mod down or empty was a mod tap down equal self.active keys dot get 0. Actually, and this is only if we're the primary board, so that's this one. So just put it all in here for now. Okay, if for the primary board and the mod tab key is held down. Wait a minute, we don't want to do this more than once, right? Actually, it doesn't matter. We can just keep asserting shift, right? So we can say if now minus empty down is greater than equal to, here's, I'm gonna just hard code this again. Then we want to push the shift key down, right? So self dot modifiers or equal to. So there's where we're making the decision to do this. And then when they release it, this will be still true, and then that's where we deassert shift, right? Okay, so then that takes care of hold. To do tap, though, I need to handle this simulated key press, right? So that's this, which we don't have yet. Let's add that. So that would go around here, right? That's another B tree map. U8 to U64. So that's like which keys are simulated, and then at what time they're simulated, so that we know when to deassert them. Okay, so then I need to put it here, right? Simulated keys, B tree map new. Okay, and then we added it here. When we make the decision, like when they release the mod tap key and it hasn't reached the tapping term, then we insert the key, we assert the key, right? So that means I also want to do a key codes add immediately, right? Oh, which we don't have, so I need to add that to register key up, which happens here. There. So we can actually have a key press happen on key up, which means I also need base. Okay. Then I need to do the deassert, which is, I guess we can do it down here at any time right here, right? So that can, we'll just take that out. So basically going through and seeing like if we're done asserting a simulated key, right? So I guess we would iterate, right? So like let's make a collection of the keys that we need to deassert first. So that would be let simulated keys done equals self dot simulated keys dot iter dot filter map. So we get the key and the downtime, and we need to make a decision about it. And then we're going to end up collecting them, right? Vector like that. Okay, so the decision and how to map it would be if now minus downtime is greater than or equal to, let's do 5 milliseconds. Then we would do filter map wants an option, right? So it'd be some key, else none. So that gets, what's wrong with it? Forgot a bar there. So that gives us a vector of what keys we need to release. So then we'll just iterate through them. So for key in simulated keys done, we do two things, right? We do self.simulated keys.remove. Key is what type? Is it a reference? It is, so just key. Oh, this is a vector of references? Yeah, so this needs to be dereferenced. Yeah, it's just a U8, so then remove that. And then we actually have, whoop. Actually, that's all we need to do. So then the ones that are still simulated, we need to make sure they are in the key report. So, yeah, so for, was it key and downtime, which we don't need, in self.simulated keys. Actually, I guess we could do it here. Can we do side effects in filter map? It's probably not a good idea. We want to borrow that because we're not going to change it, right? Yeah, then it's just key codes dot add code, or oh shoot, I need the code, not the key. Can I just do it at register key down? No. It's just base plus key. Okay, why don't I just do base plus key then? Okay, and then what is this telling me? Oh, quick fix. Use keys. All right. So then I need to make sure add doesn't add the key more than once, right? Yeah, so this should do something like see if key codes contains the key. So like if self.keycodes.find was it iter find or any? I can just do find. Find returns. I can do any, right? Any. Which one's best here? Find? Or is any? I guess any, because we only really care about the bool, right? So any, and then key code? Well, I can't use the same name, so what would I use instead? Other key code? Key code equals other key code. Then we want to return, right? So if the key is already asserted, we don't want to add it again. This protects against that, because we don't want to add it more than once, right? Actually, hold on. We're always making a new one. Do I need to worry about this? Maybe I don't. Yeah, maybe I don't. So then I can remove that. We're not going to actually add it more than once, are we? Yeah, I think I don't need to do that. All right, so then am I done? So we have all the tap keys, and then we have all the simulated keys, and then we all have all the peer keys, and they all get added up. Let's just try it. Build it. And then program it. Get to see my keyboard actually reprogram itself right now. Hopefully it doesn't crash. If it crashes, I'll be sad. Okay, it didn't crash. Let's try. Okay. Actually, I should put it here. Okay, the tap didn't work. I didn't break the other keys, but the tap didn't work. Tap was supposed to generate a 1 key. What is it doing here? It's adding it twice? I should probably print out the modifiers while we're doing this, right? Oh, there it generated 2 1s. Okay, so I got bugs. Is it driver? Yes, it's driver. Hey there, silly queen. The code I'm working on is being loaded into this microcontroller, which is the brains for this prototype keyboard. So I'm trying to implement what QMK does called hold+tap, where if we press this button down and release it quick enough within 250 milliseconds, then it's just like a normal letter, like F or like 1 in my case. But if we hold it down long enough, it becomes a shift key. And it's obviously not working. In fact, I'm seeing it doubled, which is probably why Windows didn't want to actually print it. Well, there I got a 1. Okay, well let me see, how would it get added twice like that? Let's see. So here's where we would register, right? If the key is held down, we would add it to active keys. Fine. If the key is not 0, it's false. Receive greeting false, so we won't add it to the key codes yet, right? But we will register under active keys. Okay, so then we get down to here, and we say, yes, actually, it's active, But this should be false, so it shouldn't do that yet, right? Simulated key should be empty. So this should not do anything. This should not do anything. Okay, then how are we getting... How is this... We're not simulating it, right? Okay, maybe I need to log more messages. Let's log more messages. So... let's log here, log info, deasserting shift. Actually, I ought to print that first before I do anything. And here we'll say simulating 1. Okay, and then I need to actually log where we're asserting shift, which should be the tapping term, which is right here. Asserting shift. Okay, and this should be hold on. If we're okay, start simulating, we'll have a stop simulating down here. Right here. Okay, and then that's fine. Okay, let's build this. Control C, yes, build. When in doubt, add log messages. Oh, COM port delay. What am I gonna do while the COM port delay? Maybe admire my printed keyboard case? Chassis? Look for problems on it? I mean... it's pretty nice. Actually, I guess we can continue looking for bugs. All I had... oh, now it's done. Programming. I have a bug somewhere, I just need to figure out where it is. Alright, let's try this again. So if I press and hold, it didn't do anything until I released it, and it said, start simulating 1, and then for some reason it put it in the key thing twice, and then it said start simulating 1 again? Did I... oh, I forgot to say stop. That probably was a stop down there. Okay, if I press 2, there's no 3, there's no simulation. If I tap it, I got a start stop. So is shift not working at all then? Yeah, I don't think the shift is working. What does that tell me? Okay, the between the start and stop is 5 milliseconds, so the simulation time is correct. But the tapping term is certainly not correct. Right, it should have asserted shift at this point. Because I'm still holding it down. Let me think, why would it never assert shift? We didn't receive the greeting. Is this 0 wrong? No, that's the key number, right? Hold on. Oh, we added base plus key. Okay, no, this is... No, that's correct. It's this one. Key is 0, right? Yeah, so active keys will have 0 in it. So it should return some. Now minus down greater than or equal to 250 milliseconds. That should have worked, right? Why didn't it? Okay. Let me at least, oh, before... Actually, let's add some... Let's record when, keys get put into the active set. So we'll do it here. Info key active. And then where do we remove? Right here we remove. So inactive. All right, let's look at this one. I have an error. Oh, I need to actually put the key. Program. Oh, okay, that's bad. We're flooding the log. Okay. Oh, we can't escape. Yeah, actually I needed this to go here. Okay, just kill that. I don't know if I'll be able to program now, actually. I might have to go back to the old programmer. Let's see what happens. Yeah. Oh, no. It got one half of the keyboard done. Okay, well, then I can just reprogram the other side by disconnecting it and then connecting it to this side and then reprogramming it, right? Except for that window I need to kill now. Program. There we go. I didn't have to resort to the old programmer. Hold on a second. Sorry about that. Okay. Still connecting? Okay. I'll be patient. I know, but indeed. Alright, so... Oh, interesting. We're adding it multiple times every time it's held. Oh, that's the problem. It's resetting the timer every time. Okay, that's the bug. Okay, I know what it is then. This should only insert it if it's not there, so we don't want to do insert. We want to say if self.activekeys.entry key if let I forget how the syntax of this. I guess I'll just look it up. I'm not really that good at memorizing this stuff, so I usually just look it up again. Entry. This one. It returns this. So it'd be like alloc collections B, well, we don't want, yeah, B tree map, right? And then vacant. If let collect alloc collections B tree map entry vacant. And it would be entry equal that. So basically if it's vacant, then we're going to insert it, and then yeah. Then it's going to be entry dot insert this. There we go. So we look it up. If it's not in there, we add it with the current time. If it's already in there, we're not updating the downtime, but we're still putting the key code in there. Right? Yeah. Okay, so this will work. So build that. Hopefully I fix the bug, and then the mod tap will work. And I'll be happy. My Windows machine does this sometimes, like 20% of the time, where it just takes a while to connect to the board. I'll be patient. Maybe while I'm waiting, I should just check this in. Why not? We'll just get ready to check it in. Yeah. Well, now it's connected. Okay, here we go. Oh, it's not... Again. Connecting. All right, we'll be patient. Yeah, open another shell. Let's just get the commit out of the way, right? So this is work in progress, adding experimental mod plus tap functionality. Okay, meanwhile, okay, it's ready now. So I forgot to move that line. That line needs to go here. No big deal. Let's hope we don't get... Oh, I was hoping that wouldn't happen. The delay in connecting. All right. Wait, did it? Oh, yeah. Okay, I guess we'll just do micro changes while we're waiting. Git commit. How come it didn't add that? Okay, there. Now it's staged. So this is only log key active when it wasn't before. All right, git push that. Oh, the programmer's running. Again. It's like lag time. Okay, assuming that I got it to work, what am I going to work on next? Oh, no. So this handles cases 1 and 2, right? What about 3? Well, this implies that I have another key, which is a different modifier, right? We want to actually hold all modifiers until, if a mod tap decision is pending, we want to hold it until it's done, right? Okay, let's see this working now. Okay, key 1 active, key 1 inactive, key 2 active, key 3 active. Oh, we actually saw a bounce there. Look at that. Look at that bounce. So it went active, and then it went inactive, and then it went active again. Okay, anyway, 1. Oh, shift asserting is asserting a lot of times. So a tap is active and inactive, simulating a 1. We have the key in there twice for some reason, and then only once, and then stop simulating. Okay, I need to find out why it gets active twice, and I also need to only print asserting shift once. Where does shift get asserted? How come I'm not seeing it? There it is. I guess what we do is we just see if it isn't asserted yet. If self.modifiers and 2 is not equal to 0, is equal to 0, then print asserting it. Actually, then we also don't need to assert it again if it's... No. Yeah. We only need to print it and assert it. What's it telling me here? Oh, I could combine these two? Collapse them. Yes, please do. So if the tapping term is expired and we haven't asserted shift, print the message and assert it. Okay. Okay, so the other thing is that why is it getting added twice? It happens in start simulating. So, oh, I think I know why. I think I might know why. I think because we're actually putting it in the key report immediately, and I don't want to do that. Yeah, it's right here. Yeah, if it's being simulated, we don't need to add it twice. There. What are the chances that we'll be stuck on connecting again? Oh, we have a warning? A warning? Oh, yeah, we don't need key codes or base anymore then. Woohoo! Just key. Cool. So build. Spell it correctly. Program. Again, the connecting delay. Okay. Go back to this. So I suppose we want to hold down until a decision is made. Actually, it's until the simulating is done. So I guess we want to preserve all modifiers until, yeah, until all simulated key presses have gone out, right? And here we would deassert. I guess so. I guess in addition to modifiers, we'll have like preserved modifiers. So control becomes a preserved modifier the moment that we start the tapping term, right? So even if you release control, it's still preserved. And then here's where the tapping term expired and we generated a shift. We would stop preserving it. So that means I need to make one of these other keys a another modifier like control to test that. Okay, let's test this now. Okay, cool. So if I tap it, I get a 1. If I hold it, I get a shift. I think it's working. So let's test it out. Oh, that sucks. It's not registering with Windows. Maybe I need to hold it for more than 5 milliseconds? It's not getting through all the time. Okay, so I need to increase the simulation length. But let's see if shift works. Hey, look at that. Shift works. Okay, so let's increase the simulation time. Right here. Let's make it 10 milliseconds. There's an error. Oh, wait, what happened? Oh, a whole bunch of extra letters got added. Gee, I wonder how that happened. It might have been because of a keyboard. Okay, there we didn't have that connection delay. Maybe my luck is returning. Yeah, all right. Okay, so now it's 10 milliseconds. Still not seeing it all the time. So how long does it actually need to be held down for? I guess I'll just keep doubling it until it works. So we're going to 20 milliseconds now. I guess it fundamentally will be the rate at which the host is polling us, right? So I guess it must... Worst case, it must be more than 10 milliseconds, so we'll try 20. E, F, 10, 11, 12, 13, 14, done. Okay, here we go. Hey, it's working. Oh, there it didn't work. It's working more often though. So what, more than 20 milliseconds? I'm just going to keep doubling it until it reliably works. So we're going to double it to 40 milliseconds now. Gotta get rid of the ones. Three, four, five. Hey there, Resubaka. I'm doing hold+tap. This kind of stuff. Where if you tap a key, it means one thing. If you hold it down, it means something else. So tapping it, I'm getting a 1. Is it reliable now? Yeah. So if I hold it down, it's shift. Okay, but the rolling press I'm not handling yet. So I need to handle that next. So we got tap working now. And then if I hold it down, it becomes a shift key. Neat. Like a tonal language for your fingers. There, Dr. Padawan and Utsby. Are you hearing that on the microphone? So I have Cherry MX whites on the left, and they're really loud, clicky. Yeah, I think you can hear that, right? But on the right, I have Cherry MX browns, and they're pretty silent. On my final keyboard, they're all going to be browns. I actually arrived today. I got a box of 65 Cherry MX brown switches. So I got this working, so let's check it in. And git commit git hold+tap working. Why 2 different switches? Because I didn't know which kind I liked better. So I got a sample of 10 whites and 10 browns. So there's 6 of them on here, and I have another 2 loose ones here, a white and a brown, just to show people what they look like. You can tell if it's a white or a brown because you look at the color of the stem. Brown, white. And then I have 3 more in 2 different bags behind me. So obviously I need more than the sample of 10 to make a real keyboard. I need 36, so I had to buy more. And I decided on browns. The whites are just too loud. My wife doesn't like it. If I were to ever bring it to work, they wouldn't like it either. Too loud. You weren't referring to the key sounds? You just meant the different meanings based off press timing. Reminds you of Tonal. Oh, I see. I thought you guys were hearing the switches. Yeah, so I'm not coming up with this stuff from scratch. I'm looking at how hold+tap works with QMK, kind of replicating that. So for the rolling thing, that's this right here, right? Nested press of another key within the tapping term. So here, it becomes a shift because we had another key press. So I guess what we want to do is we need to know if we're still deciding what a key means. So I should have like a flag that says so, right? And if we are and we get another key, we need to remember that that key was tapped, right? And then we would simulate it at the end of the tapping term. I actually don't know if this is right. Why would we wait to the tapping term to simulate that J? Empty's behavior is decided when empty is released, which is here. But why does the J come out way over there? I'm not going to go by this. I think I'm just going to go by the beginning of this, where normally it would be a tap. But if you roll onto another key, we got to now remember that it's not going to be a tap, even if it's shorter than the tapping term. So how am I going to do that? I'm going to have to remember which keys are currently undecided, right? Like an undecided key map. And if there are any at all, then we got to queue these key presses, right? To be simulated at the end. Or maybe we just have one simulated key. Maybe just a single slot for one key. They don't have an example, but what if we held down MT shift and hit JK really quick? Would we see capital J, capital K? I don't know. Have you ever accidentally pushed random text to get testing the keyboard? No, because I usually build it first before I check it in. So I've avoided doing that. And what about silent reds? I actually haven't tried those yet. The reds are what? They're linear, but I like the tactile feel of the browns. I like the feeling that there's a moment at which like you can feel it activate. Reds, as I understand, you don't feel that at all. It's just linear. So, but I haven't given the reds a chance. I have to admit that. How am I going to handle this? Let me think about this. So, we should have something that says there's at least one key that hasn't been decided yet. Maybe I have a counter for that. Because we know when the tapping term expires for a key, or if it's lifted, we can decrement a counter. This could also be used for the preserving modifiers, right? Yeah, so I'll have a counter for undecided modifier MTs. And if it's non-zero and we get any kind of key, then they get queued. Well, any kind of key whose decision... Actually, I guess any key is delayed, right? Yeah, okay, I think I know what to do then. So... let's have, like, keys pending decision is I don't know, it could just be U8. Okay, we need to remember to increment that when the key is registered down. Actually, it would be the else for this, right? Hold on. That's a huge struct. It is a huge struct. It's basically the state of our entire keyboard, right? Along with all the resources we have, like all the row and column pins, the USB device stack, the watchdog timer, the interface to our ring buffer. Yeah, we have a lot of state. Found the reds too light and switched to the blacks, which are slightly heavier. Rather tactile clicky, but people run. Well, what about these tactile non-clickies? Why go linear if you like tactile? That's what I'm wondering. I understand the difference in like how light or heavy it is, but like there's also that difference between linear and tactile. Okay, where am I going now? Oh, right, down here. On register key down. Not found silent tactiles to be silent? I mean, it's pretty silent. There's the sound of it bottoming out. I guess there's a little bit of sound. Yeah, maybe there's a little bit of sound. Pretty quiet compared to the clicky ones, though. I'm trying to get this logic correct. I think what I want to do here is else. Well, no, we always want to. We always want to do that. Okay, I'm going to do it this way. If it's a special key, but then I also have to remember. Let's see, let mute bool activated. Why did I put the type there? I don't know. I want activated. And then this, I'm probably writing this really badly, but that's okay. It's 1 in the morning, almost 2 in the morning for me. I gotta finish the stream soon because I gotta get some sleep. If activated, then we want to self dot keys pending decisions plus equal 1, right? And then it's decided in 2 places. It's decided if the key goes inactive, so that's here, right? Self dot minus equal 1. Oh, not in both. It's only in the case of if it here. It was decided to be a shift, so we deassert shift. Here it hadn't been decided yet, so now it is decided. So the other place where it's decided is on expiration of the timer right here. Right? Okay. So then what we want to do for normal keys, I guess. How do I do this? I think I just need to have another map of pending keys or something. Make my struct even bigger. Okay, pending keys. B tree map. Actually, it's just a B tree set in this case. Pending keys. I probably need to import btree set, right? Yep. Okay, and then that happens in register down, right? Right here, it'll be else if self.keys pending decisions is greater than 0, then self.pending keys dot insert key. Right. So if we have yet to make a decision about a mod tap key and another key gets pressed, we're going to hold on or remember that it's pressed but not added to our key code list yet. Right. If it's released, well then we don't do anything anyway, right? It wasn't active in the first place. Okay, so then yeah. Okay, actually that means there are 2 places where we need to do this thing, right? Yeah, it's these 2 cases. Yeah. One is this. Yeah, so it'll be if self.keys pending decisions equals 0, then we want to take all of the pending keys and simulate them. So for key in self.pending keys dot drain. I can't just drain them? Okay, I'll just iterate them and then clear them, I guess. Self.pending keys dot clear. Self.simulated key dot insert dereference key, and then we need a now. Right. See, habits die hard. You can buy silicone rings to soften the bottom out. That's the problem. Where would you put the silicone ring? Like under the, like between the base of the key switch and the key cap? I see that, yeah. There's some space there. Yeah, okay. That would make it truly silent? Is that like a key silencer? Only problem I have is that this logic is in 2 places, so... What if I make a function called, like, self.key key pending, yeah, key decision made. Yeah, and then that's just a function, so function key decision made. Paste. Oh, we need a now. Okay, so now is a U64. Key decision made now. So then I can copy this and paste it in where key up happens right here. There we go. So in either place, we'll simulate any keys that were pressed while we were still making decisions. I think that should work. Let's try it. Build. Oh, you know what I should also do? I'm printing out start simulating. I should print that in the other places too, right? Find all references. Yeah, let's... I don't want a constant there. How about we start simulating key? And then I'll just copy that for now since it's just log message right there. Yeah. And then this should match it, right? All right, let's do that. Depends on the case / mounting plate to get less sharp impact noise, but still, yeah. The mounting plate I made myself. Designed it in Blender. It took 4 revisions, but I got to something I like. I need to make a mounting plate for the final product too. I have the chassis, but I haven't made the mounting plate yet. All right, my friends, I'm almost done with the stream because it's almost 2 in the morning. I just kind of wanted to get rolling key presses working. Once I'm done with this, it's mostly an experiment at this point. I need to clean it up, refactor it, and then make it more, like, reusable. Instead of hard coding the key codes, I need to, like, make them, configurable. That's gonna be another whole stream unto itself, I think. Wow. Oh yeah, you have a good weekend too, Utsby. Yeah, once I get this working, I think I'll check it in and call it a night. I wish I didn't have to wait for this, though. I guess while we're waiting for that, I can close up shop on these other windows. I don't need the PCB window open. I can close KiCad. There it goes. Alright. I guess I can just be optimistic and get the commit message ready. Don't need that many windows. Git commit. Add. Were we saying nested press or rolling press? Support rolling / nested press during mod tap. All right, ready. Okay. I don't think that worked. It didn't work. Why didn't it work? Key active, key inactive. Wait, what? Okay, let me do it again. I don't know which log message to start looking at, which one not to. Yeah, I think there's more to the story. All right, so first key 0 active, then key 0 inactive. Very short time after. Oh, that was a bounce. Okay, we can't. I'm gonna need debouncing. That was definitely a bounce. Let's try again. All right. Okay, here's, I don't think it bounced this time. Why the right side is counting so slow? 102.30. What's going on with the right side time? Anyway, active. And then that's the A. Actually, what's key 4? That's lowercase a, I think. No, that's lowercase b, isn't it? Let me press it again and see. Lowercase a. All right. Oh, it's on the other keyboard. That's why it's not working. But if I did it on the same keyboard, it worked. Okay, yeah, all right. So I'm not treating keys on the same side as I am keys on the other side. So I have to treat any peer keys the same way. That makes it more complicated. Actually, it makes it a lot more complicated. Actually, this is going to be the same problem as when I start adding mod tap to the right side. Okay, I think the solution is, instead of transmitting a key code list, it should just transmit a key number list, and then they just kind of get incorporated with the keys that are held down on the left hand side, and then handled all together. Yes, I need to restructure the code. But the good news is that the rolling key stuff should work if I do it all left-handed. So that's 2, but then that's shift 2 works. 2, shift 2, or shift 2, 2, shift 2, rolling key press. Okay, if I release the shift first, if I do a true rolling thing, it doesn't work. But actually, that might be what it's supposed to do by default. If I release it first, what happens? Is there an example of that? I don't see it. Like, what happens if you do empty shift to F, J, release empty shift F, and then release J? I'm seeing bounces too. Oh, wait, no, it did something different. Active, active, inactive, simulate 0, simulate 1, and then 1 inactive. Oh yeah, it got in there twice. Why are we simulating 1? Oh, because it was still pressed? Okay, that's a bug. That, how do I show it all again? I want to show it all. Scroll bar's fighting me. There we go. Start simulating 1, but we already added key 1 in there, so it's in there twice. Okay, what did I do? How did that happen? Probably because it was still held down. And yeah, it was scanned after. That's right. Okay. I think the problem is we register that one and then we register that one, right? So in here, when we make this decision of it being pulled up, we decision made, right? So this corresponds to that, and then decision made, that corresponds to that, but the key's still being held down, so then it actually adds it directly on key down right here, because it's 0 by that time. Oh shoot, okay. I mean, I guess I add back that code that I had in key codes. This one. So make sure it's not added twice, I guess. Let's add that back in there. Program. Bada. Bada. Ah, delay. I'll just commit this while I'm waiting. Protect against same key code being added multiple as too many characters. Protect against multiples in key code reports. All right, trying to test this again. So, two. Okay, it's not doing this properly, I think. Key 0 active, key 1 active, key 1 0 inactive. Simulate. So no, it shouldn't do this. Oh, I forgot to add something. Oh, shoot. Yeah. It's supposed to make it a shift 1. Okay. Yeah, okay. I know what I did wrong then. It's on key up. This. We don't want to do that. We only want to do this if there are no keys pending. So if self.pending keys is empty, then do that. But if there are pending keys, then we go into decision made and oh, we need an else then. Else we need to assert shift. So actually I wonder if that should be moved into decision made. But yeah, this has to be done up here. I'll refactor this later. So if there are no pending keys, it's a tap. Otherwise, it's a shift. And the decision is made. When do we deassert shift? Do we deassert shift? What happened here? Oh, that shouldn't be there. Deassert. I don't see it. Hey there, Endurin. Yeah, I'm up too late, Endurin. Raimu time works. Yeah, I just have too much fun and I stay up too late. But it's the weekend, so that's fine. Okay, I don't have any code path that deasserts shift in this nested key case. I think where we're gonna do it is where we dole out those pending keys right here, right? Actually, it would be after simulated keys is done. So where is that? That's down here, right? Looking for it. Oh, but we have to wait a little bit longer. Oh, this is complicated because we had to put it in the report and then change our modifiers. So that would be way down here. So I hate making my code look ugly, but I think I got to do it, right? Yeah. So we should say let mute last simulated key done equals false. And then this would be I think it would be here, right? If self-simulated keys is empty. That's true. And if that becomes true, then after we do this, so if last simulated key done, then we want to deassert shift. If it was asserted. If this and self.modifiers and 2 is not equal to 0. There. The total hack. I'll have to figure out how to do this in a better way, but it's way too late for me to figure it out now. I just want to kind of get it to look right, to do the right behavior. Yeah, it's 2 a.m. here, Endurn. It's way too late. That means it must be 11 a.m. for you? Is that right? Okay, so 1, 2, 1, 2, hold, and rolling. No, rolling key press is still not. Oh, no, now it is sort of working. Oh, and I've broken it. I totally broke it. Oh, shift is probably... Yeah, shift got stuck. How does shift get stuck? Yeah, I broke it. I gotta reset it. Reset. Which button was reset? This one? No, this one. Okay. I broke it somehow. Tap still works. Mod still works. Wait, deasserting shift and then asserting shift? I guess it's okay because we're still holding it down. Oh, now it's broken. Okay, so what happened here? Key 0 active. Key 1 active. Okay. Key 1 inact. I don't understand my own log messages here. I need to watch this more closely. Maybe I need to sleep on it too. What controllers am I using? I'm using Raspberry Pis. RP2040. Shift got stuck there. Oh, the board is just stuck. I gotta reset the board when it gets into that state. Wait, shift is still stuck? Yeah, that's weird. Yeah, shift is unstuck now. tap is reliable, and then mod tap is reliable. It's just the rolling keys I have some kind of bug in it. So many little boards to keep track of these days. Yeah. They look like Arduinos, don't they? The Raspberry Pi, that's their first microcontroller. It's really teeny tiny. So it's basically it's competing in that same space as Arduinos. No, I totally messed it up. I'm gonna have to sleep on it. Hey, but I got basic mod and basic tap working. I got tap and hold both working. Where I'm kind of getting stuck right now is this rolling press. So this one. And the one that's not sort of indicated here, where like if you hold J slightly longer, like you roll through the keys, that's also not working right. But I'll fix that some other time. Probably on Monday. Probably Monday. Unless I want to stream during the weekend. I haven't decided that yet. So I checked this in. I think I will check this in. Also, I'll just say that this is my attempt. So git commit. We don't need this window. So work in progress. I'll just say work in progress. Attempt to get a nested rolling mod tap working. And it just barely fits there.
Beep, beep.
Wait. That's not really saved, right? Yeah, okay. Git push that. All right. Well, my Monday or your Monday, true. Or it could be your Sunday and my Saturday. Who knows? Well, I thought that no one else would be streaming this hour, but there are some people streaming. Crazy. Who to raid? Oh, Jula Day is streaming again, so why don't we raid them, because they're also working on making a mechanical keyboard. Hold on. Yeah. So Jula Day 97, Korean, but also speaks English, so rated them last time, and they're also working on their own keyboard. Sort of a nice segue from this stream, right? So hope you enjoyed the stream. It's been a great 4 hours. I made a lot of progress. I made a 3D printed chassis. I don't know if Endorn saw that. I think Endorn, you did see this, right? But yeah, anyone who hasn't seen it, the first part of the stream I worked on making the other half of this while I was printing this. So this is the chassis that the keyboard's going to sit in. Yeah, it looks nice. I have to print out the other side, and then I have to wait for the PCB to come in. So maybe by Monday I'll have the PCB in, and then I'll actually be assembling the keyboard. We'll see. Anyway, I hope you enjoy the streamer rating too. Good night. Thanks for watching. Bye.